Hi grade 11s and welcome to this video. In this video, we are going to be working on the Gauteng Province Provincial Examination, and this is for June 2022. So this paper is for 2 hours and it is 100 marks. So it's not really a long paper. Remember, the video may be longer than 2 hours despite the fact that the paper is 2 hours long. Okay, so we see the instructions. Just make sure to round off to 2 decimal places unless stated otherwise. And when we move on to question 1, this is what we have. So let's go ahead and start with question 1, 1.1. Okay, so 1.1 says, for which values of x is the square root of x plus 3 over x plus 1 all squared real? Okay, so the question is asking, for which values of x will this expression be real? Well, for us to be able to figure that out, we need to understand what real numbers are. Okay, so let's think about real numbers and really the number system. And this is probably why they were constantly teaching you about the number system every time during the beginning of the year. Real numbers are basically these types of numbers. So with real numbers, to understand what real numbers are, I could go ahead and start explaining the entire diagram, including rational and irrational numbers and natural and whole numbers. Or we could look at it from this angle. To figure out what real numbers are, we could just find out what exactly non-real numbers are. And so if we find out what non-real numbers are, we would know that the exact opposite would be real numbers. Okay, so we just need to show them or give them the values of x for which this expression is going to be real. So let's think about it. How would this expression be non-real? How can we actually make that to not be real? Okay, so when you're looking at number systems, non-real numbers, you would have noticed that there was one particular type of non-real number that they always spoke about, and that would be the square root of a negative number. Okay, so as long as you're square rooting, and let me not use x so I don't confuse you, but let's just say even the square root of -1, this would be regarded as a non-real number. And the reason why it's really a non-real number is because just think about it like this. When you square root a number, for example, the square root of 4 is equal to 2. You're really just asking yourself, what do I multiply by itself twice? That would give me 4, and that would be 2, right? So we know the square root of 4 is 2 because 2 times 2 is 4. And if I ask myself, what is the square root of, for example, 9? That would be 3 because 3 times 3 gives us 9. But if I ask, what is the square root of -4? Remember, the rule is that it needs to be the same number multiplied by the same number. The only way you can get a -4 is by saying 2 times -2. But that's the problem. These are not the same numbers. 2 is not -2. Okay, if it's -2 degrees, that is very different from 2 degrees temperature-wise. So that shows really they're two different numbers. So this is where non-real numbers come from. Because we see that you cannot actually find the square root of a negative number, when you square root a negative number, it is non-real. Okay, so keep this in mind. Square rooting a negative number makes that number non-real. But also remember that it's not necessarily only square rooting. It's also fourth rooting a negative number, and sixth rooting a negative number, and eighth rooting a negative number. As long as the root is an even number, it cannot actually be rooted when you're even rooting a negative number, if that makes sense. If you're square rooting a negative number or the fourth root of a negative number, it is non-real. Okay, so now that we understand what exactly non-real numbers are, really the square root or the fourth root of a negative number, what we can do with that is actually figure out what would make this expression real. So for this expression to be non-real, you know now that if you square root a negative number, it's going to be non-real. So think about it. This expression, do you notice that this expression is being square rooted? And I said if you square root a negative number, it's going to become non-real. So it means that if everything inside or under this radical, under the square root is negative, then this is going to be non-real. So now we know that for that expression to be non-real, this is what needs to happen. For it to be non-real, that title, x plus 3 needs to be negative, okay? That numerator needs to be negative, or the denominator needs to be negative. Now, how do we show them that it needs to be negative? Negative numbers are numbers that are less than 0. So it means that x plus 3 needs to be less than 0, or x plus 1 all squared needs to be less than 0. Because if they are negative, then it means that your expression would be non-real, okay? So I know if I say if they are negative, it's kind of like, but you're saying that the numerator is negative and the denominator is negative. Not really. I'm not saying they're negative at the same time. I'm saying either one should be negative, and that's why we're using the word or. Okay, that's really why the word or is usually used in quadratic equations. Okay, so I'm saying either this, the numerator, needs to be negative, or the denominator needs to be negative. Now remember, that is what's going to make this non-real, but we need to show them the values of x for which it's going to be real. So for it to be real, it just has to be the opposite of this. So it means that the numerator, for it to be real, the numerator, x plus 3, would have to be greater than 0. And the denominator, so we'll say, the denominator, the x plus 1 all squared, would have to be greater than 0. Okay, now we just have to look into this and actually just see if we're making sense. So you still have to look at it and just see if it's really going to produce all real values for this expression. So x plus 3 is the numerator. I'm saying that it needs to be greater than 0. Now, I just said that because I was trying to explain what real numbers would be if we compare it to non-real numbers. Okay, but let's just think about it like this. If that is greater than 0, it's going to be real. But what about if it's equal to 0? Would it still be real, that numerator? Okay. If a numerator is equal to 0, so let's say you have 0 over 2. 0 over 2, even if you use a calculator, it will just give you 0. And 0 is a real number, so it will still be real. So we need to add that extra rule as well. We're saying that x plus 3 is greater or equal to 0. It can be greater or equal to 0 because even if the numerator is equal to 0, your expression is still going to be real. Okay, so let's keep that in mind. And let's also look at this just to see if there's anything else that we need to do here. So with this one, can this be greater or equal to 0 as well? Can it also be equal to 0? Well, you have to think about that now. That is a denominator. If you make your denominator equal to 0, for example, 2 over 0, what happens there? If you make your denominator equal to 0, you get a number that is undefined. So the question would be, are undefined numbers real? And the answer to that is no. The thing about undefined numbers is they're not also non-real. They're not real, they're not non-real, they're just undefined, meaning we haven't really found a way to define them yet. So we can't really include that. It means that you cannot let that denominator be equal to 0. So let's keep that in mind. This x plus 1 all squared must not be equal to 0 because it's going to be undefined, and undefined numbers are not real or non-real. Okay, as long as they're not real, we can't include them. So this would be really what we're working with. So I can get rid of that. That's really just what we use to find what we have now. Okay, so now that we have this, we can just go ahead and solve for this inequality. And this inequality is quite simple to solve because it is just a linear inequality. So we can go ahead and say that we're just going to take the 3 over. So it means we have x is greater than or equal to, and that becomes a negative 3 when it comes over. Or, and then we can also come to this, we're saying that if you have a square there, you can get rid of the square by square rooting both sides. Normally we'll put a plus and minus here, but 0 is not positive or negative, so it doesn't matter. We can just say x plus 1 is greater than 0, and we have a linear inequality as well. Let's go ahead and take that 1 over. So it means that x just needs to be greater than negative 1. Okay, so this is what we have. We can also work on a restriction just in case that any of these include the restriction. So here, if we're saying that x plus 1 all squared must not be equal to 0, then you can just square root both sides in this equation. And so x plus 1 must not be equal to 0, meaning x must not be equal to specifically negative 1. Okay, so now another way to just put this all together, right, is you can try to represent it on a number line. So let's just see what it's going to look like. If it was on a number line and we have -3 and we have -1, the answer is saying that x needs to be greater or equal to -3. So if we have -3 here, x needs to be equal to it or greater than it. A closed circle is for when it is equal to it. Okay, so, or greater. Now think about the numbers that are greater than -3. Where would they lie? Would they be on the left-hand side or the right-hand side? They'll be on the right-hand side. So it means that your arrow is going to point like that. Numbers that are greater or equal to -3. Do you see that that would also include the -1? Because -1 is greater than -3. So it means that as a whole, if we're concluding, our answer can just be x is greater or equal to -3, but x must not be equal to -1. And that will be our solution. So that would be the values of x for which this expression would be real. I know that was a long explanation, but I just really wanted you guys to understand it in more detail. Okay, so finally done with this question, and we can move on to the next question. Okay, next question 1.2.1 says we need to solve for x in this equation. You see that is just for 1 mark because they have already factorized it for you. So you just have to solve. Don't go and start distributing, because then you're going to get to a trinomial that you're going to have to factorize again, and then you end up realizing that they already did it for you. Okay, so what you need to do here is, since they're already factorized, you're just going to equate each bracket to 0. You're saying that this x plus 4 is either equal to 0 or that x minus 1 is equal to 0. And so therefore x is equal to -4 or x is equal to +1. And remember grade 11th, the logic behind this is they're saying that two things are being multiplied and they give you 0. So it means that either this one is multiplied by this, let's say this was a number, 0 times anything gives you 0. So we're saying either this bracket is equal to 0, or if you, let's say this was just a number on its own, and we were multiplying it to this one, and this one was 0. Okay, that bracket was 0. A number times 0 again will give you 0. So it either means that this bracket is either equal to 0 or that bracket is equal to 0 for us to be able to actually multiply both brackets and get 0. So that's the logic behind that. And that's why we use the word or. Okay, so that is our answer. Moving on to the next question. Next question 1.2.2, we have to solve for x, but we need to correct to 2 decimal places. So if you need to correct to 2 decimal places, then it already means that you're going to have to use the quadratic equation. But for you to use the quadratic equation, this needs to be in its standard form. You see that the 14 is still on the right-hand side. It needs to come over. So we're just going to rewrite this. This is going to be 3x squared minus 2x, and that becomes a minus 14 is equal to 0. Okay, now we can go ahead and use the quadratic equation, which is x is equal to -b plus minus the square root of b squared minus 4ac all over 2a. Okay, so as you can see, in standard form, the quadratic equation, right, is ax squared minus, or plus rather, bx plus c is equal to 0. So that means that the a value is 3, our b value is -2, and our c value is -14. So we can just go ahead and substitute this into our equation. So x is equal to negative, and we have b. B is -2. So in place of that, we put -2. And then plus minus the square root of, we have b squared, which we know is -2. So -2 all squared minus 4. And then a is 3. So we're going to substitute 3. And then c is the -14. So -14 all over 2a. So 2 and a is that 3. So you can go ahead and put this onto the calculator. I will start with the plus, and we're going to just round off to 2 decimal places. Okay, and when I try the plus, I get x being equal to 2.519, rounded off to 2 decimal places, that is 52. Or, and then if we go ahead and change that sign to a minus, then we get x being equal to negative 1.852, rounded off to 2 decimal places is 85. And those would be our answers there. Okay, so x is equal to that, and x is equal to that. And that is for 4 marks. Okay, so you're getting a mark for taking it over, putting it in standard form. You're getting a mark for substitution, and you're getting a mark each for your solution. Okay, moving on to the next question. Okay, question 1.2.3 says we have to solve for x in this equation. And we have x squared minus 2x is equal to 18 minus 45 over x squared minus 2x. Do you notice that there was a repetition there? Okay, now even if the repetition was not there, okay, even if you didn't see it, if you attempted to solve for x in this equation, right, you would have looked at it and just said, okay, so since we have an 18 here already, we might as well take it over. So I'm just trying to show you what would have happened if you didn't try to use the k method, right? You would have said x squared minus 2x, then maybe minus 18 is equal to negative 45 over, because there's a minus there, over x squared minus 2x. And then what? Then maybe you would have looked at the fact that there's a denominator with variables and said, okay, maybe we just need to get rid of that denominator. And you could do that by multiplying both sides by that denominator. You could have also seen it as if you are cross multiplying. So I put this as a fraction over 1. And so you'd have said 1 times that is negative 45. But then you would have to say this entire thing multiplied by this entire thing. You see the issue with this? This is x squared minus 2x. And you'd be multiplying it with x squared minus 2x minus 18. And you see where that now becomes a problem when you start distributing. When you start distributing, you have x squared times x squared, which gives you x to the power of 4. When your equation already has a 4th power, it means now that you have 4 possible solutions. And now you have to figure out how to actually factorize that. That's going to be really complicated. And so this is why you should, whenever you see that there's more than one x squares, right, and you see that on the denominator, one of the x squares on the denominator, you need to pause and look for repetition. So do you see that we have x squared minus 2x and x squared minus 2x? They're the exact same thing. What we can do is use the k method substitution. And that works like this. You take whatever was being repeated, and we're going to say, let k be equal to that thing that was being repeated, which is x squared minus 2x. Okay, so let's go ahead and replace it with k. So we're going to say, there's x squared minus 2x. We'll replace it with k. It's equal to, we have 18 minus 45 over, we have x squared minus 2x, replace it with k. Okay, so now that we have this, we can just solve for it the same way we were actually working on it when I said, okay, let's go ahead and just try and solve for that. So I can take the 18 over, so I can say that's k minus 18 is equal to, and we have negative 45 over k. Then we can also see that, okay, the k is on the denominator. And so what we can just do is get rid of the k by multiplying both sides by k. You can do that. Or you could have seen it as, okay, I can just take this and put it over 1 and just cross multiply. So 1 multiplied by negative 45, which gives you negative 45 is equal to, and then k minus 18 times k, which is fine. We can actually multiply those. So k minus 18 times k, since k is one term, right, expression, I'll put that in front, and it's being multiplied by k minus 18. Okay, so if we simplify this, it's negative 45 is equal to, distribute, that's k squared multiplied by negative 18k. And you see now this is already starting to look like a trinomial. So just take this over. So it means we're going to have nothing here, 0 is equal to k squared minus 18k, and that becomes a positive 45. Okay, So let's go ahead and factorize this expression. 0 is equal to the trinomial, so we open up two brackets. What times what gives you k squared? That will be k multiplied by k. And then what times what gives us 45, but that will give us negative 18 in the middle. So let's think about factors of 45. 45, we know that we can have 9 and 5. But rather than just finding it randomly, let's actually just find it the proper way. So normally we would look at factors like, okay, 1 and 45, but obviously that's not going to work. That's never going to give us a negative 18 in the middle. So let's try the next one. Can 2 go into 45? No, but 3 can. So we can try 3 and 15. So 3 times 15 is 45. And when added together, they need to give you 18. So let's think about it. Remember, this is a positive 45. So if you're multiplying these two together, they need to give you positive 45. But when added, they should give you negative 18. Well, if they're both positive, when you add them, they can never give you a negative. So because only the middle is negative, it means they need to be both negative. Okay, so negative 3 minus 15 gives you negative 18. But negative 3 multiplied by negative 15 gives you positive 45. Okay, so that's how we know those are our factors. It's minus 3 and minus 15. Let's go ahead and solve for k. So it therefore means that we'll just take the negative 3 over the equal to sign, like k minus 3 equals 0, of course, right? So k is equal to positive 3, or k is equal to, same thing here, take it over, positive 15. Okay, so great, we have solved for k, but that does not solve for x. So we need to look at it and let's just see, how can we solve for x? Well, we have to go back to where x was, which was here. So since we said k is equal to x squared minus 2x, then in place of k, I'm just going to substitute. So since I know that k is equal to x squared minus 2x, I'm going to replace it. So k is x squared minus 2x, which is equal to 3. And I'll do the same thing here. K is x squared minus 2x. So x squared minus 2x is equal to 15. And now you see we have a trinomial again. Just take your 3 over. So this is x squared minus 2x minus 3 is equal to 0. Solve for the trinomial, open up two brackets. And we're thinking about factors of x squared. We have x times x. Factors of negative 3 that give you a negative 2. See, this is a negative 3, okay? So since it's negative, the only way to get a negative 3 is 1 must be negative, 1 must be positive. But we know that the factors of 3 is 3 and 1. 3 times 1 gives you 3. But which one should be negative, which one should be positive for us to get a negative 2 in the middle? The 3 should be negative and the 1 should be positive. So negative 3 plus 1 is negative 2. So that's minus 3 plus 1. Okay, so those are our factors. And so it means that x is equal to 3 or x is equal to negative 1, because we take that positive 1 over the equal to sign. Same thing here. You see, we also have a trinomial. Just put it in standard form first. So x squared minus 2x. We're taking the 15 over, minus 15 is equal to 0. And so if we factorize this, this is equal to 0. We have x multiplied by x, and 15. Let's split 15. Let's think about factors of 15 that can give us 2. And I'm immediately already thinking about 5 and 3. So 5 and 3, but it's negative 15, meaning 1 needs to be positive, 1 needs to be negative. So if the 5 is negative and the 3 is positive, negative 5 plus 3 gives you negative 2. So those will be our factors, negative 5, positive 3. Okay, so we can just go ahead and solve here. X is equal to positive 5 or x is equal to negative 3. And look at that. Look at how many solutions we have. X is equal to 3, that's 1. X is equal to negative 1, 2. X is equal to 5, that's number 3. And x is equal to negative 3. 4 solutions. Do you see that when we took that expression and we started multiplying, did you remember that we ended up with an x to the power of 4? The highest exponent in your equation tells you the number of possible solutions you can have. So because there was a 4, it means that there were 4 possible solutions. And as you can see, we also have 4 possible solutions. It does not mean that we have 4 solutions in this case. It doesn't necessarily mean that it always has to be 4 solutions since you had x to the power of 4. But it means that there were 4 possible solutions, but in this case, we actually had exactly 4 solutions. Okay, and that is how to solve that one. You have to use the K method. You have to learn to identify where repetition happens. Okay, it usually happens like that, where that would be on the denominator. Okay, so that is 1.2.3, and we can go ahead and move on to 1.2.4. Okay, 1.2.4, we have an equation with surds. So this equation with surds, we're just going to go ahead and say, first thing you always have to do in equations with surds is you're going to have to isolate the surd. See, because in this equation, if you're trying to solve for x, this right now is a problem, okay, to solve for x. So you need to leave this on its own so that you can try and individually get rid of the surd. So we'll leave the square root of 5 minus x, and we'll go ahead and take this positive 1 over. When you take the positive 1 over, we still have the negative x. The positive 1 comes over and becomes a negative 1. Okay, so we have isolated the surd. Now look at the equation. What is the next thing that is stopping you from solving for x? What is the thing that looks like a problem right now? That would be your square root. So how do we get rid of a square root? We get rid of square root by doing the opposite, which is squaring. But this is an equation, so what you do on the one side, you must do on the other side. So I square that, and I also need to square that. Okay, so when you square this, it goes ahead and cancels because they're the inverse of each other. So we have 5 minus x is equal to, and when you square this, this is what happens. Okay, so you can go ahead and say, okay, I'm going to rewrite it twice, negative x minus 1, negative x minus 1, and then start distributing. You can do that. Or you could use this method where you're going to look at it like this. When something is being squared, a binomial is squared, you're just going to say the first term, we will square that. The first term is negative x. When it is squared, negative x all squared gives you positive x squared. Okay, then second thing, square the last term. Negative 1 all squared gives you positive 1. Okay, then to get the middle term, you take the first term, which is negative x, and you multiply it by the second term, which is negative 1. And that, first of all, just gives you a positive x. Then you take that and you double it by multiplying it by 2. And so in the middle, you have a positive 2x. Okay, so that's the steps. Square the first term, square the last term, multiply the 2 terms, and multiply by 2. Okay, so now that we have this, we can go ahead and just put it in standard form. You see, it's going to be a trinomial. So just take these ones over. So 0 is equal to x squared plus 2x. And I have a negative x. When it comes over, it becomes a positive x, then plus 1. And then that comes over and becomes a negative 5. So 0 is equal to x squared. And we have plus 3x. 1 minus 5 is negative 4. Okay, so just factorize. 0 is equal to, open up 2 brackets. We have x multiplied by x to give you x squared. Factors of negative 4, that can give us 3 in the middle. Well, we can think about factors like 4 and 1. But remember, since this is a negative 4, 1 has to be positive, 1 has to be negative. Which one should be positive and which one should be negative for you to get a positive 3 in the middle? 4 should be positive, 1 should be negative. That way, 4 minus 1 is 3. Okay, so we have positive 4 and negative 1. Okay, so we can go ahead and just simplify. It means that x is either equal to negative 4 or x is equal to positive 1. Remember, we're taking it over. Okay, so with this, please note, this is 5 marks. Let me show you where the marks are going. You get a mark, first of all, for isolating your surd. Okay, isolating the surd. You get 1 mark for that. The second mark comes for squaring both sides. Okay, so because you squared both sides, you get a mark. The third mark comes from putting it in standard form. The fourth mark comes from getting your answers. The last final mark actually just gets given to you for checking that these are the correct answers. Sometimes they're both correct, and that's fine. Sometimes one is correct, the other is not. And sometimes they're both not even correct. Okay, because there's some equations that there are no real values for. Okay, so we're going to go ahead and check that these are the correct answers. So I just take my equation, which was that 5 minus x, I'm just leave that blank, plus 1 must be equal to negative x. And I'm going to substitute my first solution, which is negative 4, and it needs to balance out. So 5 minus, meaning the left-hand side needs to be equal to the right-hand side. So 5 minus, the first one we have negative 4. 5 minus negative 4 plus 1 must be equal to negative 4. Okay, because I'm just substituting. So it means that here we're going to have a positive 4. And 5 minus minus 4 just gives you 5 plus 4, which is 9. Square root of 9 is 3. So that is just 3 plus 1. And 3 plus 1 is 4. That perfectly balances out. So we know that this is a solution. We'll keep that. Let's try 1. So if I substitute 1 into this, 5 minus 1, and then this is just minus, and we have 1. 5 minus 1 is 4. Square root of 4 is 2. So 2 plus 1, okay, must be equal to negative 1. As you can see, that is not true. Okay, 2 plus 1 is 3. 3 is not equal to negative 1. So now you know which one is not the correct answer. 1 is incorrect. So this is where your extra mark is coming from. This is where your extra mark is coming from. It is coming from canceling this one, telling them this is not my solution, but this one is my solution. So you can, if you like, say x is equal to negative 4 only. And then you get your extra mark for validating one and saying the other one is invalid. Okay, so that is it for the third. So 1.2.4 done. And we move on to the next question. Okay, next question 1.2.5, and we have an exponential equation. So with this exponential equation, you see that we have 3 to the power of 2x, right, plus 1, minus 4 multiplied by 3 to the power of x, and then is equal to negative 1. Now this one, it's not that clear, but I want you to see, you have a 3, right, to the power of, yes, it's a 2x, but technically there's an x on the exponent. And you also have a 3 to the power of an x. That's another case of repetition. When you see a specific variable, right? So maybe it can be a base and exponent, but you see an expression or a term being repeated. It's usually a situation where you're going to have to use the K method, okay? So with this one, I would say let's stop and let's just first of all isolate that exponent. You know how you were taught that when you have the bases being the same, like a to the power of m, for example, being multiplied by something with the same base, right? You're going to do what? You're going to leave the base the same and you're going to add the exponents. So m plus n. Okay, so what we're going to do is we're going to use this rule, but we're going to use it to break that up. So since we have 3 to the power of 2x plus 1, that was definitely created by saying 3 to the power of 2x multiplied by 3 to the power of 1. And that's how we're going to break that up. Then we have minus 4 multiplied by 3 to the power of x. And we have minus 1, which we can just take over, bring it over, okay, which becomes a positive 1 is equal to 0. Okay, so now that we have this, and you'll see why we brought the 1 over now. So now that we have this, you see that we have 3 to the power of, x, and we have 3 to the power of x. Those are repeating themselves. If you still don't think it's repeating, look at how you can rewrite this. You can rewrite it as 3 to the power of, and instead of writing the 2 first, because really the 2 and the x are next to each other because they're being multiplied. So instead of writing the 2 first, you could have written the x and say that, okay, that's being multiplied by the 2. You could have written it like that or like this, because either ways the x and the 2 would multiply. And then this is being multiplied by 3, of course, to the power of 1, which we can just write as 3, minus 4 times 3 to the power of x plus 1 is equal to 0. Do you now see that there is a repetition going on here? 3 to the power of x is being repeated throughout this equation. Because we have that being repeated, we're going to use the K method. The K method says we need to say let K be equal to whatever was repeated. So let K be equal to 3 to the power of x. So we're going to replace wherever we see 3 to the power of x, we replace it with K. So there is 3 to the power of x. I replace it with k. But then I have outside a squared. So that's really just k squared multiplied by 3. K squared times 3 is 3k squared. So I can rewrite that as 3k squared. So 3, we have our k and squared. And then we have minus 4 and 3 to the power of x again, which we replace with k. So k, and then we have plus 1 is equal to 0. So look at that. That is a trinomial. We can factorize this trinomial. So this is one of those trinomials where you have x squared, the coefficient of x squared being something else other than 1. Okay, it's not like just k squared. Okay, it's 3k squared. So the coefficient of k squared has a number. So I'm going to use a method called the factor method. Okay, this is a known method. Normally I used to use the cross method, but I'm using a different method now just so that we can see different ways of doing things. So to factorize this, we're going to do this. The first step is to take this and multiply it with the 1. So it's really just the first term's coefficient times the constant, that last term. So 3 times 1 is 3. Now we're going to think about factors of 3 that give us negative 4 in the middle. So 3 is a prime number. So it only has 2 factors, 1 and 3. That's all, right? But remember, this is positive 3 that we had when we multiplied. It gave us positive 3. Think about how this can become a negative 4. Okay, because it's positive 3, if you make this negative and this negative, when you multiply it, negative 1 times negative 3 gives you positive 3. But negative 1 minus negative 3 also gives you negative 4. So do you see that? Those are our factors. And this is how we're going to write these factors now. So we're going to say 3k squared. And in place of this negative 4, we're going to rewrite it like this. So I would suggest that I know that we have negative 1 and negative 3. And you could have written the negative 1 first. But I would suggest that you put next to this, right, whatever has a common factor with it. So look at that. Between the 1 or negative 1 and the negative 3, which one has a common factor with this? It would be the negative 3. So I'm going to put this as minus 3. But remember, this is supposed to be negative 4k. So minus 3k. And then I still have my negative 1. So I'll call that minus, instead of saying negative 1, it's minus k. And together, if you say negative 3 minus k, they still give you negative 4k. You see, we're not changing the value of the expression. We're just changing the way it looks so that we can better factorize and simplify it. So then we still have the plus 1 outside. So plus 1 is equal to 0. So after doing that, now we're going to use grouping. We're going to group, or really just put in brackets, the things that have common factors. We've already put them in the right order. So these two go together and these two go together. So out of this first group, we're going to take out a common factor. The highest common factor here is we have 3 being common first of all and k being common. Open a bracket, what is left? So you can say 3k squared divided by 3k, which will give you k. And then negative 3k divided by positive 3k gives you negative 1. Okay, so that's what we have there. Now, out of these two, what can you take out as a common factor? What's common between negative k and positive 1? It's actually negative 1. You can take negative 1 out as a common factor. Open up a bracket, and what is left? Negative k divided by negative 1 is positive k, and positive 1 divided by negative 1 is negative 1. Now, do you see that in the brackets we have the exact same thing? So the idea behind this is really just grouping. We're looking at these two terms and we're taking out what is common between these two terms, which would be the bracket of k minus 1 that repeats itself in these two terms. So we're taking k minus 1 out as a common factor, and then we open up a bracket, and what do we have left? You can take this and divide it by your k minus 1. You see that k minus 1 will cancel. You'll be left with 3k. Or in other words, you're saying what multiplied by this would give us this, and that would be 3k. Okay, and then again, take this, divided by that. You'll be left with your negative 1 is equal to 0. So this is what we have. We have either k is equal to negative 1, or you can say 3k minus 1 is equal to 0, but you're just going to take that 1 over. So it's really just 3k is equal to positive 1. Divide both sides by 3, and k is equal to 1 over 3. Okay, so we have our solutions for k. K is either equal to -1 or k is equal to positive 1 over 3. But we need to solve for x, not k. So substitute what k is back into the equation. So k is equal to 3 to the power of x. So in place of k, I'm saying 3 to the power of x is actually equal to -1. Now come back to that. And here, 3 to the power of x is equal to 1 over 3. Okay, so let's go ahead and try and solve for this. If you are given an equation that says 3 to the power of x is equal to -1, can you actually solve for this? An exponential expression, right? If you have 3 is a positive base. If you raise it to any exponent, even if it's -2 or even -1, it's always going to give you a positive number. 3 to the power of -1 is 1 over 3. 3 to the power of -2 is 1 over 9. See, these are all positive numbers. So it means that you can never take a positive base and raise it to an exponent and it gives you negative. So this equation has no solution. Okay, so x has no solution here. And that's perfectly fine. Okay, let's go ahead and solve for the equation here. 3 to the power of, and I'm just going to start on this side. So 3 to the power of x is equal to 1 over 3. How do we solve for this equation? Well, do you see that they both have 3's? And that's a good thing. You just have to try and make the bases the same. Since this is a base of 3 and it's carrying the x, you need to make this a base of 3. How do we make 1 over 3 a base of 3? You can do this by taking that 3 on the denominator and moving it to the top, to the numerator. When you do that, we still have the 3 to the power of x. When you move that 3 to the numerator, there's a consequence for this. The consequence is that whatever exponent was on the 3, right, which is actually a what? An invisible 1. That exponent is going to become negative. So this becomes a -1 that we have there. 3 to the power of -1 is 1 over 3. So you see the bases are the same in an exponential equation. If the bases are the same, you have all the right to equate the exponent. So x is equal to -1 only. Okay, so this equation has only one solution, and it's one of those K method substitution equations. Okay, so 1.2.5 is done, and we finally move on to the next question. Okay, 1.2.6a, we have an inequality, and this is for 2 marks, so we need to solve for x. So do you see that this is a quadratic inequality because the highest exponent is 2, but it's not a trinomial. It's a binomial. We have 2 terms only, this and that. Those are the only terms we have. So how do we actually solve for this inequality? Well, you have to factorize. When you have a trinomial, you use the trinomial method of factorizing to factorize the trinomial. But this one is not a trinomial. So what other methods of factorizing do you know? What other methods of factorization do you know? We can use highest common factor. Just take out a highest common factor between these 2 terms. What's common between the first term, x squared, and -3x? It would be the x. So take x out as a common factor, and what are we left with? X squared divided by x is x, -3x divided by x is -3, and this is less than or equal to 0. Okay, and then we would have to solve for the inequality. So to solve for this inequality, you can treat it like it's an equation, as if this was an equal to. How would you solve for this? Well, it's saying that one thing multiplied by another thing is equal to 0. It either means that this first thing, the x, is equal to 0, or the second thing, the x minus 3, second number, is equal to 0. And so here, you would take that -3 over, and it becomes a +3. Okay, but remember, this is an inequality. It said less than or equal to 0. This was just to help you to find your critical values. So it means your critical value is 0. So we have x and 0 like that. And the other critical value is 3. So I can even get rid of this, and I can just leave it like that. Okay, so since this is what we have, we can just go ahead and solve now. Okay, to solve for this inequality, since we have this, there are 2 methods that you can use. You can use the table method, or you can use the graph method. In grade 11, I would advise that you use the graph method, because this is something you're going to be dealing with a lot. You're going to be dealing with graph interpretation, so it is better to just get used to it. So to deal with this, let's use the graph method. We're going to go ahead and put an x-axis, and then we're going to look at this expression or that equation. That equation, because it has x squared, the highest exponent is 2, it means it is actually a quadratic, right, equation. And quadratic equations, think about the kind of graph it forms. Quadratic equations form parabolas. Now this parabola, is it going to be concave down or concave up, smiling or sad? Well, the value of ax squared, which is something I wrote already, so ax squared plus bx, the value of a here is 1. So if a is equal to 1, it means that your a value is positive. A is greater than 1, so you have a smiley face. So this is what we have. We have our parabola like that. And we can put down our critical values now. So first critical value we'll put down is the 0, because it's the smaller one, it goes to the left, and then we have the 3. Okay, now that we have our critical values down, let's go ahead and solve for this inequality. But let's also just remember that this says this expression must be less than or equal to 0. Since it's less than or equal to 0, we need to also fill that in here. We're going to still find out for which values it will be less than, but let's deal with that equal to 0. You see, if it's saying that it's equal to 0, it's really just saying that when you take this expression and you substitute this value, it should give you 0. And we can test that out to see whether that's true or not. So the critical value we have is 0. 0 squared minus 3 times 0 gives you, think about it, 0 squared is 0. Negative 3 times 0 is 0. So that means that's just 0 minus 0, which is 0. So we can see that it really does give us 0 when we substitute the first value, critical value. We can also try it with 3. Let's go ahead and substitute 3. So in place of x, we put 3. So that's 3 squared minus 3 times 3. What does that give us? 3 squared is 9. And then we have negative 3 times 3, which is negative 9. So that is 9 minus 9, which is 0. You see that when you substitute your critical value, it really does give you 0. So we can say x is equal to 3, because that does give us a 0. Okay, we're just looking for the values of x for which that inequality will be true. Okay, so to solve for this inequality, now that we have our critical values down, what we're going to do is look at what the inequality says. It says that the expression needs to be less than or equal to 0. Okay, so that less than or equal to 0 is actually referring to the y values of this expression. The y values of an expression come from the y-axis, okay? So think about the y-axis and think about the places on the y-axis where the values are less than or equal to 0. That would be down here. These have negative values, less than or equal to 0, not up here. Okay, all of these have positive values greater than 0. So it means that you're going to have to focus on, think about it like this. If you look at this point over here, it has an x value. It's not the 0 is here. So it has an x value and its y value is positive. But we're not looking for positive y values. We're looking for negative y values. So this point, we cannot take that. Neither can we take this point because it has a positive y value. Or even this point, it has a positive y value. Even the points here, we can't take these ones. So as you can see, we cannot take any parts of this, okay? We can't take those parts of the graph. Really, we cannot take parts of the graph that lie above the x-axis because every part of the graph above the x-axis has y values greater than 0. We need to focus on the parts of the graph that lie below the x-axis. Okay, so now that we know that, I can just get rid of all of this. Now that we've found the parts of the graph that lie below the x-axis, we just need to find out what exactly the x values are going to be. All you can do is line these values to the x-axis. So do you see, look at where these values are. They're here. These are the values that we have. So think about what they are compared to 0. These values are going to this side. So it means that these are values that are what than 0. Values that go here are greater than 0. So to solve for x here, we're saying that x is greater or equal to 0. Do you see that? The arrow helps you with the inequality. And then for the 3, look at the values that we have, right? We don't have anything pointed here, but we have values here. these are values that are going to the left-hand side of the 3. And values to the left-hand side of the 3 are values that are less than 3. So it means that x is less than, again, the arrow helps you, the inequality, less than or equal to 3. Now there's one final thing you have to do in this situation, and the only reason why is because, do you notice that these arrows are pointing towards each other? When the arrows are pointing towards each other, they're speaking about the same set of numbers. And because they're speaking about the same set of numbers, we can actually write them as a single inequality. So how we'll do that is we'll say therefore, then you can go ahead and put your x in the middle. Then your smaller value here, smaller critical value, which is 0, bigger critical value, which is 3. And now you're going to rewrite it like this. So you're going to go ahead and say, look at this inequality. We had x being greater than 0. But when you compare the x to the 0, do you notice that the inequality, the mouth, the open part, right, is facing the x. So you need to rewrite it like that. When I have my 0 versus my x, my inequality needs to face the x. And don't forget your equal to on the bottom. Same thing with the 3. We're going to look at the x versus the 3. Do you see that the open mouth, right, that mouth, it's facing the 3. So you need to rewrite it like that. The inequality needs to face the 3, and don't forget the equal to. So it means that your inequality is x is greater than or equal to 0, but less than or equal to 3. And that would be your question. That would be your answer for 1.2.6a. And the last question would be second last question is, in question 1 is 1.2.6b. Okay, question 1.2.6b, we have, if f of x is equal to x squared minus 3x, write down the values of x for which f of x minus 3 is less than or equal to 0. Okay, f of x minus 3. This question actually is simpler than what you would think it is. You see that we're still using the same expression here, right? We've solved for that. So there's no way they would make us go through that whole trouble of solving for this just so that we can form a new equation again and solve for that again. Okay, so let's think about it like this. We already know the answer for this one. We know what the solution is when f of x is less than or equal to 0. That's what we solved here, where this expression was less than or equal to 0, since this now is f of x. Okay, we just need to find out where f of x minus 3 is less than or equal to 0. What is the difference between this and this? In this one, we just have a minus 3. So it just means that take your original answer, and wherever you see x, just subtract 3 from it. And so this is what's going to happen. This is our original answer. Our answer is, for this expression, of course, is where x is greater than or equal to 0, but less than or equal to 3. To solve for this one, you're just taking wherever you see the x, subtract the 3. So that's what I'm going to do here. I'm going to say x minus 3, right? And I'm going to rewrite the equation, the inequality, less than, greater than or equal to 0, but less than or equal to 3. And now you just need to solve for this inequality. So it's like a double inequality. So to solve for this inequality, you need to get rid of, to solve for x, you just need to get rid of this negative 3. Well, you can only get rid of it by taking it over. So to take it over, because it's like I called it, a double inequality, you need to take it over on both sides. So taking it over there and there. So when you take 3 over there, you still have the 0, and that becomes a plus 3 when it comes over. Negative 3 comes over. We have less than or equal to. We have x in the middle. Negative 3 goes over, and we have less than or equal to 3, and that becomes a plus 3. So you see, they're just both plus 3's that go over. And so it means that we have 0 plus 3, which is 3. Okay, we have that, and x, that. 3 plus 3 is 6. So it really just means that x needs to be greater than or equal to 3, but less than or equal to 6. And that will be our solution for that. Okay, so that is our answer. And we just have one more question for question 1, which is 1.3. So let's go ahead and solve that. Okay, so 1.3 says, the sum of two numbers is negative 10 and the product of the same numbers is negative 600. Determine the value of the two numbers. Okay, they called it two numbers. They didn't give it a value. So what we can do is assign a letter to it. Our two numbers, the first number can be x and the second number can be y. So they said the sum of two numbers is negative 10. When you hear the word sum in maths, sum means to add. Okay, so we're adding there. And then they said the product of those two numbers is negative 600. Product means to multiply. So the sum of these two numbers, x plus sum of the two numbers plus y, is negative 10. And they told us that the product of the same numbers is negative 600. And we know product is to multiply. So that means x multiplied by y is negative 600. And do you see what we have now? We have a simultaneous equation. We just have to solve for x and y in this simultaneous equation. So in simultaneous equations, you're just going to have to look at the linear one, or whichever equation can become linear. So in this one, it's quite simple. That's our linear equation. And we're going to go ahead and call that equation 1. And by default, this one is equation 2. Okay, so from equation 1, we're going to form equation 3. Since x and y are just nicely on their own, I'll just make x the subject. So x is equal to, I still have my negative 10, and I'll take the y over and becomes a negative y. And this is now our equation 3. Okay, so now that we have equation 3, you're just going to go ahead and substitute equation 3 into the equation we did not touch yet, which is equation 2, into equation 2. So our equation 2 says x times y, but we know what x should be. It should be this. So negative 10 minus y being multiplied by y. That looks awkward because you have two terms being multiplied by one term. You can just put the one term in front of it like that. So that's y times that is equal to negative 600. Okay, let's simplify what we have here. Y multiplied by negative 10 is negative 10y. And y multiplied by negative y is negative y squared. And this is going to become a trinomial, but I'll still leave the 600 here, the negative 600. Okay, so we just have to be careful, that's all. So let's go ahead and take everything here over. And the reason why is because I can see that the coefficient of x squared is negative. It should be positive for us to be able to factorize. So I'll just take that over. So it means 0 is equal to, that comes over and becomes a positive y squared. That comes over and becomes a positive 10y, and that stays negative 600. Okay, so just factorize this, factors of 600. 0 is equal to, we have y and y. Let's think about factors of 600. So I said 600 divided by 30, and I get 20, and I know that 30 and 20 can actually give me 10. So these would be the factors we would use. So let's think about how they can give us 10. Remember, this is a negative 600. So because you have negative 600, think about how you need to put those. It means that if it's negative, one needs to be positive, one needs to be negative, but your middle must be positive 10. For that to happen, I will leave the 30 as positive, the 20 as negative, because 30 minus 20 is positive 10, and 30 times negative 20 is the negative 600. Okay, so I'm going to say positive 30 and negative 20. Okay, so that's just a way that you can do that if you were maybe not using the quadratic formula. The quadratic formula is useful, but sometimes it will cost you marks because you're supposed to get marks for factors. If you don't factorize, they can't give you those marks. Okay, so this is what we have. We can go ahead and just simplify. Now, y is equal to, take the 30 over, negative 30, or y is equal to positive 20 when you take it over. Okay, I can call this equation 4. And then to find the solution for x, you can use equation 3. So we're going to substitute equation 4 finally into equation 3 to solve for x. So that's the last thing we do. Sub equation 4 into equation 3. So that is, we have x is equal to negative 10 minus y. That's negative 10 minus y. So negative 10 minus y, that is what x is equal to. So x is equal to negative 10 minus y is negative 30, so negative 30. Okay. Or x is equal to negative 10 minus our second y is 20, minus 20. Okay, so we'll solve for that now. This is just x is equal to negative 10. When you multiply through there, you get positive 30. And negative 10 plus 30 is like saying 30 minus 10, which is 20. So x is equal to 20. Or here we have x is equal to negative 10 minus 20 is negative 30. So these are solutions for x and y. It's either that x is equal to 20, or x is equal to negative 30, or x is equal to negative 30, and x is equal to 20, which you can see they're really the same numbers. So if I'm concluding, I'll just say the values, okay, of the two numbers are 20 and negative 30. And it's fine like that. I don't have to write the or anything like that, because here y is equal to negative 30, but x is 20. Here y is 20, but x is negative 30. Okay, so the two numbers are ultimately just 20 and negative 30. Okay, so that is it for question 1. Question 1 is a total of 29 marks. This is a place that you can really score marks. Okay, so that is it for that. And we move on to question 2. Okay, so finally we are on question 2. And question 2.1 says simplify completely without the use of a calculator. So as you can see, they've given you a question with surds in it, and you have to simplify this expression. When you look at this, how many terms are there in this expression? There are 3 terms, because remember, terms are separated by plus and minus signs. There's a plus, there's a minus sign. So it means that this is 1 term, 2, and 3. Okay, so we're going to simplify the expression term by term. That's how we normally simplify expressions. Let's look at the first term. 2 square root 8. How do we simplify that? So you see the square root of 8. That can be simplified further. If you look at that, let's just put the 2 there. And just remember, whatever comes here is really being multiplied by that 2 that you still have there. So when we have the square root of 8, what you can do with the square root of 8 is split it into 2 numbers, but one of the numbers has to be a perfect square. So let's think about that. What you can do is take 8 and just divide it by random numbers, and it needs to give you a perfect square. So if you try 8 divided by 1, obviously that's not going to work really. So you can try 8 divided by 2. So 8 divided by 2 would give you 4. So that means that 4 times 2 gives you 8. And you see that 4 is a perfect square number. It's a square number. So what we can rewrite 8 as is 4 multiplied by 2. Okay. Let's move on to the next part. The next one, we have 4 square root or minus 4 square root, 32. We're going to do the same thing to 32. So minus 4 is still there. Whatever is going to come after is going to be multiplied by it. But we have the square root of 32 now. So 32, let's take 32 and try dividing it by 2. So it's best to always start with 2. It will work out best. 32 divided by 2 is 16, and already we have a square number. Okay, so it means that 32 can be written as 16 multiplied by 2. You see the pattern here, multiply by 2, multiply by 2. So you can expect that one to look something like that as well. So we have plus 3, and then the square root of 50. So we're going to change 50. 50 divided by 2 is 25, which is also a perfect square. So it means we rewrite 50 as 25 multiplied by 2. Okay, so now that we have broken them up, separated them into their perfect square and the other number, which is just going to stay a third, we're just going to simplify further now. So 2, we still have 2 there. And remember, I said that when we actually find the value of this, whatever number comes outside is going to be multiplying by this 2. Okay, so since you have the square root of 4 times 2, it's really just the square root of 4 multiplied by the square root of 2. And the square root of 4 is 2. So that number is going to come here, 2. And then we still have the square root of 2, square root 2. That's what we have. This 4, the square root of 4, when we separate it as square root of 4 multiplied by square root of 2, that changed into 2 square root 2. Okay, this whole thing is 2 square root 2 because we could find the answer of that. Okay, so this is what we have. 2 multiplied by 2 square root 2. We will simplify that in the next line. Then we still have minus 4. And the same thing's going to happen here. You're square rooting this number and you're square rooting this number. The square root of 16 is 4. So that comes here multiplied by 4. But the square root of 2 is still a third. So that stays the square root of 2. Okay. And then we come to the 3 plus 3. The square root of 25 is 5. So multiply by 5. The square root of 2 still stays the square root of 2 because it's not a perfect square. Okay, now we can just simplify further. It means this is 2 times 2 square root 2. 2 times 2 is 4. So this answer for this whole thing is 4 square root 2. Then here, minus 4 times 4 is minus 16. Minus 16 square root 2. And then we have 3 times 5, which is 15. So positive 15 square root 2. Okay, now do you see that they're all in terms of the square root of 2? Surds really behave like letters. They're like algebra. So you can kind of see this as like 4x minus 16x plus 15x. The same way you would simplify this expression is the same way you would simplify that. So whatever your answer is, it would be something x. This one would be whatever that number is, square root 2. Okay, that would be acting as if it is your variable. So when we simplify this expression, you can go ahead and decide to start with, if you're using the rule of BODMAS, you see that addition comes before subtraction. So you could do that. But the thing about it is it doesn't really matter when it has to do with adding and subtracting. Okay. So because addition has a commutative nature, right? It means that you can put it in any order and it will still give you the same answer. Like if I said 5 plus 2, it's still 7. But if I said 2 plus 5, it's still 7. And even with subtraction, because if you said 5 minus 2, that gives you 3. But you cannot say 2 minus 5 because then that means you're not really taking the number that you saw here. The number here is not a 2, it's a negative 2. So that's negative 2 and plus 5, which will still give you positive 3. Okay, so that's what I mean by addition has a commutative property. So it's really addition and subtraction. Okay, so what we're going to do here is you can go ahead and use BODMAS and decide to start with the addition first. I'll just do that. So I will start with the addition. Since these two are being added, I'm saying negative 16 square root 2 is being added to positive 15 square root 2. So we have 4 square root 2 still there. Negative 16 square root 2 plus 15 square root 2. That's going to give you a negative square root 2. Okay, it's like saying negative 16 plus 15, which gives you negative 1. So that's why it's negative square root 2. Remember, the square root 2 is like your x. It's like your variable. And so 4 square root 2 minus square root 2 is just 3 square root 2. Remember, again, it's like algebra, like 4x minus x is 3x. Okay, the square root 2 is like your variable. So that's our answer, 3 square root 2. Okay, moving on to the next question. Okay, in the next question, we have another expression that also has surds and rational exponents. So we just have to simplify this expression. Before even just simplifying it, let's look at it and just see the kind of things they've put here. So here we have a 3 to the power of negative 1 over 2. And then we have a surd here. Something you should know about surds is if, for example, you have the square root of 6, for example, multiplied by the square root of 3. What you can actually do is, because they're both square roots, right, and they're being multiplied, you can actually rewrite it like this. It's the square root of 6 multiplied by 3. Okay, they can be written under the same root since they were both square roots. But please note that this is not going to be the same for something like the square root of 3 multiplied by the cube root of 3. Because in this case, this is a square root and this is a cube root. So no, they cannot be put under the same radical or the same root. Okay, so what we're going to do is let's just go ahead and use this rule that we know here. Because we know that if you have a square root and a square root, they can be put under the same root, then we can think about taking this and actually putting it back as a root. Okay, and how we do that is like this. When you have a square root, right? Let's say the square root of, and let's just make it an awkward looking number. So let's say the square root of 5 to the power of 2. Let's make it 3. Okay, you can rewrite this as 5. So we're just going to rewrite this so that it has a rational exponent. So it has a base and then an exponent. So you're going to say the inside exponent, which is the 3, divided by the outside exponent. Now the outside exponent in the square root is actually an invisible 2. So there's an invisible 2 there. So it's actually 3 over 2. So it means that 5 to the power of 3 over 2 is the exact same thing as the square root of 5 to the power of 3. Okay, so just like that rule works, we can actually use that to put this back into a surd. Okay, so that 3 to the power of negative 1 over 2. Remember, it is inside exponent over outside exponent. So it means that the inside exponent is this over here, the negative 1. And I'm going to just give the negative to the 1 so that that square root is not a negative, okay? So what we have there is 3 inside, but then the inside exponent is negative 1. The outside exponent is a 2. So that's a square root. I don't have to write the 2 because square roots, the 2 is actually invisible. Okay, so I'm going to leave it like that. And remember, the reason I'm leaving it like that is because of that rule of surds. When you're multiplying with the same root, you can actually put them together. Okay, so going to the 12 now. So with the 12, we have, I would leave it like that really, because I really want those two to multiply. And then this one we have to sort out. So we have plus and we have the cube root of, in brackets, 3 square root 3. Okay, so we can break this up like this. First of all, you're going to have to always start from the inside going to the outside. So I still have to rewrite this cube root. It's still the cube root, and inside the bracket, inside here, we have a 3. So I have to simplify this square root of 3 first. Now, since that is a square root 3, to simplify this so that it can have a base that is not a surd, we can just rewrite it as the 3 here. Then you're going to take the inside exponent, which is a 1, over the outside exponent, which is a 2. So do you see that we have 3? It's been multiplied by 3 to the power of 1 over 2. That's what that changed to, okay? In the next line, we'll simplify it further. So here, we still have this. Well, if you have 3 to the power of negative 1, even on your calculator, it will give you 1 over 3. So I'm going to say this is the square root of 1 over 3. That's fine. And square root of 12 still, plus, and then this part. So with this part, now that we have already made this a base of 3, do you remember the rule that if your bases are the same and you are multiplying, then you can do what? You can add the exponents. So that's what we can do there. So we still have the cube root of, now the bases are the same, so we leave the base the same and we add the exponents. So the exponent on that 3 is 1, plus the exponent on that is 1 over 2. 1 plus 1 over 2, you can use a calculator as well. It's just going to give you 3 over 2. Okay, so this is what we have, and we're actually getting there now. So we have the cube root, and then this is what we have. Okay, so it's the square root of 1 over 3, square root of 12 plus, and now we can go ahead and simplify this, make this a base of 3 just on its own. So it means we're going to have 3, and we're going to take the inside exponent, which is 3 over 2, and it's going to be divided by the outside exponent, which is that 3. Okay, and I'm just going to simplify this already on the screen like this. Since it's 3 over 2 divided by 3, instead of writing it like that, I could say 3 over 2 divided by 3. When we're dividing by a fraction, this needs to be a fraction as well, so you can put 3 over 1. The rule for dividing fractions is that you need to tip and times. So in tip and times, you're going to take the thing that is dividing that number and you're going to tip it. It was 3 over 1. So we'll tip it, meaning swap the numerator and denominator. So it becomes 1 over 3. And then the times part just means change your division to a multiplication. So that's what that becomes because of tip and times. And so we have square root of 1 over 3 being multiplied by the square root of 12 plus, and this is now 3 to the power of, and then we can multiply. Now, you can go ahead and start multiplying, but you can also look diagonally to see if anything cancels. I see that we have a 3 and a 3. So 3 would divide by 3. They would cancel each other. Okay. And because of that, now we have there's a placeholder of 1. 1 times 1 is 1 over 2 times the placeholder of 1 remaining here is 2. Okay. That's a good look. Okay, that is a very good thing to happen because this is going to be a surd. So we're just going to put it back in surd form. So this is equal to the square root of 1 over 3 being multiplied by the square root of 12 plus, remember the rule is you have your base and then you're going to have your root and you're going to say the inside exponent is the numerator. So that is our 1 there. The outside exponent is the denominator, that is 2. But because this is square root, you don't have to write the 2. And because that's a 1, you also don't have to write the 1. There's an invisible 1 there. So that became square root of 3. And now we can finally go ahead and simplify and multiply. Because these two are not like surds, okay, we can't really add them. If they were like 2 square root 3 and positive square root 3, then you can add them. But they're not, so we can't add them. And what we're going to do instead is we can take the outside value and we're going to distribute. Multiplies by the first term and it needs to multiply by the second term as well. So this is finally equal to, remember the rule that I spoke about in the beginning. If you have the squares of something multiplied by the squares of something, you can put them under the same square root. So it means that here we can call that the square root of 1 over 3 multiplied by 12 when this multiplies by this. Then for the second one, we're saying the square root of 1 over 3 multiplied by the positive square root of 3. So we still have positive, and because they're both square roots, we can write it as the square root of 1 over 3 multiplied by 3. Okay, we're getting there. And then it's equal to, and we have 1 over 3 times 12. 1 over 3 times 12 is going to give you 4. So you can't say it. It's going to be 12 over 3 really, because it's numerator times numerator. The numerator is 12. The denominator by default is 1. So 1 times 12 is 12. 3 times 1 is 3. And so if you simplify this further, 12 over 3 gives you 4. Okay, and then we have plus. Same thing's going to happen here. Numerator times numerator. So we have 3 over denominator times the default denominator is 1. So that is 3. So you see 3 over 3 gives you 1. Square root of 4 is 2 and square root of 1 is 1. So your final answer is 3. And that is our final answer for that question. All of this was simply equal to 3. Okay, moving on to the next question. Okay, next question 1.3, we have an exponential expression. So, well, technically it's not really exponential because we don't have x's there, but we have values that are really big. So I want you to see what's going on here. We have 5 to the power of 2006 minus 5 to the power of 2004 plus 24. Okay, and then we have 5 to the power of 2004 as well plus 1. Do you see something being repeated? Okay, I actually see something being repeated, and what's being repeated is that 5 to the power of 2004. There is a 5 to the power of 2004 here, and it's also in here. So I can see 2 ways of working this out. Okay, we can decide to take 5 to the power of 2004 as a common factor. That will still work out. But because there's repetition, I would like to actually work through it this way instead. Remember when I said when you see something being repeated, you can use the K method. So that's what I want to do. But for me to properly do that, I want to separate that 2004 from here so that we can clearly see it. So let's go ahead and do that. A 5 to the power of 2006 is going to be in the form of, I'm going to rewrite it as 2004, right, plus 2. That's what's going to give you 2006. So I'm just breaking up 2006, not changing the value of it, just changing the way it looks. Then we have minus 5 to the power of 2004. And then, of course, the plus 24. And then over, we still have the exact same thing, 5 to the power of 2004 plus 1. Okay, so at this point, what I'm going to do is because we have a plus here, I can separate them so that they have their own base each. Kind of like if you have 5 to the power of x plus 2, you can separate it into 5 to the power of x multiplied by 5 to the power of 2. So I'm going to just do that there. So that is going to be 5 to the power of 2004 multiplied by 5 to the power of 2. And then everything else stays exactly the same. Okay, so now that the 2004s are separated, because they were being repeated, this is what I'm going to do, just to make this simpler. I'm going to say let k be equal to 5 to the power of 2004. So every time I see that, I'm going to replace it with 5 to the power of 2004. Okay, so first I see 5 to the power of 2004, I replace that with k, and it's being multiplied by 5 squared. Then we have minus 5 to the power of 2004. We replace that with k. And we have plus 24 all over. And we have 5 to the power of 2004, which is k. And we have plus 1. And now this is what we're going to do. K multiplied by 5 squared. Well, 5 squared is 25. So k times 5 squared is just going to be 25k. And then we have minus k and just plus 24. So minus k plus 24. They're not being multiplied. Over k plus 1. K plus 1. Let me just leave that k in red. Okay, so let's just look for like terms. You see that 25k and k? Those are like terms, okay? Because they're both in terms of k. That's like 25k minus 1k, which is 24k. So we have 24k there. And we have plus 24. Interesting, okay? And then we have over k plus 1. So k, and we have plus 1. And when we simplify this further, you see that we have 24 in the first term and 24 in the second term. So that's a common factor. We can take it out as a common factor. So it means if you're taking it out as a common factor, that's 24. And open bracket, you're going to be left with k plus 1. Okay, because what do you multiply to 24 to get back to 24? That is 1. Over k plus 1. And you can see those two would cancel. If you like, at this point, you can replace it back. You can tell them back that, okay, k was equal to 5 to the power of 2004. So we can just change that back and say this is just in case of any marks that could have been lost because of this. So 24, and then that's 5 to the power of 2004, replacing k plus 1 over and 5 to the power of 2004 plus 1. Okay, so do you see that we have the exact same thing on the numerator and the denominator, and we have one term on the numerator, one term on the denominator, so we are free to cancel. So those two would simplify, they cancel, and our final answer is just 24. And there we go. So all of that is equal to 24, and that is 2.1.3. We finally move on to the next question. Okay, the next question is 2.2. And they tell us given x is equal to the square root of 6 plus the square root of 6 plus the square root of 6 plus, and it just keeps going. And we have 2.2.1 saying you need to write x squared in terms of x. Okay, so let's break that question down. They say write x squared in terms of x. Let me give you an example of what they're speaking about here. So if I said we have an expression and it is, let's say, x plus y equals 5. And I asked you to write, let's say, write y in terms of x. So in terms of x. Writing y in terms of x would mean this. You're saying write y. So write y means make y the subject. So this needs to be the subject of your equation. And in terms of x just means that x needs to be included in your answer, okay, in what y is equal to. So writing y in terms of x means make y the subject, so I'll leave y alone. And so that will mean x needs to go over, it needs to come over. And so we still have 5 there and minus x. This would be writing y in terms of x. Y is the subject, x is part of the answer, okay, or part of what y is, the definition for y. Okay, so to understand what they are actually speaking about here now, they're saying write x squared in terms of x, meaning your expression needs to start with x squared is equal to, and when you have your answer here, it needs to include x. So how can we do that with what they gave us? He gave us x is equal to and all of this. But remember, x is equal to that. So since we need to write x squared in terms of x, we need to have an x squared in the first place. How do we get that x squared? Well, technically, this is an equation. So what we can do is call this our equation 1. And we're going to formulate equation 2 by creating that x squared. Okay, so let me just rewrite this. What I'm saying is I have x is equal to that square root of 6 plus the square root of 6 plus the square root of 6 plus the square root of 6. And it keeps on going, right? I have that. And I call that my equation 1. In order to get equation 2, I'm going to take equation 1 and square it, because that's the only way I can get x squared. So I'm taking equation 1. Let me just say, I'm going to take equation 1 and I'm going to square that. So if we square this, this is what happens. You square one side, you have to also square the other side of the equation, because it's an equation. The left must be equal to the right. So x all squared is x squared. We got the x squared part now. Is equal to. So how do we simplify this when it's being squared? So to explain big things, you usually have to just try and simplify it, like make a small little example of it. Then you can start understanding how that works. So if you had, for example, the square root of x plus 2, and that was squared, what would happen? You see, because it's squared, the first square root is going to cancel with that squared. And you just be left with the x plus 2. That's exactly what's going to happen here. Since we have the square root, that first square root, that's going to cancel with your squared, because they're the inverse of each other. And because of that, what's going to happen is this first 6 is not under a radical anymore. It's not under a square root anymore, because that first square root is gone now. All that is left is a 6 plus the square root of 6 plus the square root of 6 plus the square root of 6, and plus keeps going. That's what we have left. Remember that they said write x squared in terms of x, right? We have that x squared part. That is the subject. But how can this be in terms of x? Do you remember that they told you that x is equal to the square root of 6 plus the square root of 6 plus the square root of 6? Where do you see that in this equation? That would be this side, this part. That is the square root of 6 plus the square root of 6 plus the square root of 6 plus the square root of 6. It will keep going. So this is now x. So it means that we can write this as x squared is equal to, we have 6 plus x. That is our x. And that would be writing x squared in terms of x. Okay, so that is the first question. And we move on to the second question. Then the second question is, hence determine the value of x. So that's not so bad. The reason why is because this is already an equation. So we already have our expression or equation, for this. And we just need to solve for x now. So you have an x squared, you have a constant, and you have an x. This is trinomials. So we're going to go ahead and take everything over to that side. So we're going to have x squared, and we're going to take the x first, minus x, and then the 6 minus 6 is equal to 0. Then we factorize this is equal to 0. X multiplied by x gives you x squared. What times what gives you negative 6? That will give you a negative 1 in the middle. That can be negative 3 plus 2. So negative 3 plus 2 would work out for that. And so it means that x is either equal to positive 3, because we take it over, or x is equal to negative 2. But let's think about that carefully. Remember, they said write down the value, not values, value. And even if you look at this and see what x was, because x has a definition, it said the square root of 6 plus the square root of 6. Nowhere was there a negative here. And this cannot even become negative, because the thing inside the radical, okay, every number inside the square root is a positive number. So it's impossible for it to be negative. So what I'm going to do is cancel out this answer, because I know that x can definitely not be negative, and therefore x is equal to 3 only. Okay, so that is that question. And we finally move on to 2.3, which is the last question in question 2. Okay, question 2.3 says, given rectangle PQRS with QR being equal to the square root of 8 minus 1, as you can see, QR, and RS being equal to the square root of 8 plus 1. You need to determine the length of any diagonal of the rectangle. Okay, and you need to leave your answer in simplest surd form. Okay, so they gave us the dimensions of this rectangle and they want us to just find any diagonal. So I'm just going to choose a diagonal. Let's go ahead and choose this diagonal. I'm going to just call that PR. I'm going to choose PR. Okay, so let's try and find PR. So when we're looking at that, because this is a rectangle, we know that by default, this PS is going to be perpendicular to SR. And then again, this is not Euclid, so you don't really need reasons. I mean, we can put reasons, but don't really need them. Okay, so it would mean that we can use Pythagoras. So we would need this side and this side, which we have, and then we'll be able to find PR. So we actually have PS because this is a rectangle and opposite sides are equal. So you can tell them PS is equal to QR. So PS is just equal to square root 8 minus 1. You can tell them that. Okay, if you like, you can tell them because it's a rectangle, but it's not Euclid. You don't really need reasons. So I have that now, and now we can go ahead and use Pythagoras to find PR. So that is PR. To find PR, because it's a hypotenuse, it's going to be PR squared is equal to PS squared plus SR squared. Okay, so this is really just simplifying. PR squared is equal to, PS is, like we have there, square root of 8 minus 1, square root 8 minus 1, but you're going to have to square that because it's squared, so all squared. Then we have plus SR squared, which is square root of 8 plus 1, root 8 plus 1, and that is also being squared, so we also have to square that. Okay, so that's what I mean by this is just simplifying, really. Okay, PR squared is equal to, how do we actually simplify this? Do you remember that these two things, they're not really, should I say, like terms? Because one is a surd, one is a number. So you can kind of see it like with algebra when you have something like x minus 1 squared, right? You would first square the first term. So we're going to square the first term. This first term is square root of 8. When you square that, that's going to give you 8 because the radical cancels, right? The root cancels. So 8. And then the second thing is you square the second term. Second term squared, the second term is negative 1, so that becomes a positive 1. Then to get the middle term, you'll say the first term times the second term. So square root 8 times negative 1 is negative square root 8, negative square root 8. Then you're going to take that and multiply it by 2. So in the middle, what we have is minus 2 square root 8. That is this simplified. Same thing here, okay? Square root 8 plus 1, square the first term, that's positive 8. Square the last term, positive 1. Multiply the two terms, square root 8 times 1 is square root 8. And then you're going to multiply that by 2. So we have positive 2 square root 8. Okay, let's simplify. Do you see that in this expression, we have negative 2 square root 8 and positive 2 square root 8. They're the same thing, just different signs, so they will simplify, they cancel, and they become 0. When you add them, they just simplify to 0. Then we have 8 plus 1, which is 9. Also have 8 plus 1, which is 9. So 9 plus 9 is 18. So it means that PR squared is equal to 18. And we finally have to find PR, which is one of the diagonals. So you can square root both sides to find it. You don't have to put plus or minus because it is Pythagoras. It's speaking about lengths. Lengths are never negative. Then we have PR is equal to, and so you just have to simplify square root of 18 because they did say leave it in simplest surd form. So square root of 18, well, the number that we can use here is, since 18 has 9 in it, which is a perfect square, we can separate 18 into 9 times 2. 9 times 2 gives you 18. And then finally PR is equal to simplify this, you're saying the square root of 9, which is 3, and the square root of 2, which does not simplify to a simple or whole number. It just stays square root 2 as a surd. So your final answer for a diagonal, any diagonal, would be 3 square root 2. Okay, so that would be the length of any diagonal because the diagonals in a rectangle are exactly the same lengths. Okay, so that is the final answer for question 2. Question 2 is a total of 20 marks. And we finally move on to question 3. Okay, so now we're on question 3, and 3.1 says, the first 4 terms of a quadratic number pattern are -7, 0, 9, and 20. So first we have to determine a formula to represent the general term of the pattern. Okay, so just remember it is a quadratic number pattern. So in order to find the formula of it, you first need to find the first difference. So let me go ahead and put the pattern down. Okay, so to find the first difference, we're going to first of all say the 20 minus the 9. And when we subtract those, we get 11. And then 9 minus 0, 9 minus nothing stays 9. And then 0 minus -7. Remember, that is 0 minus -7. When you multiply two negatives, they become a positive. So that gives you +7. So this is the first difference. And then we have to find the second difference. So we'll find that by saying 11 minus 9, which gives us 2. And then 9 minus 7 is 2. And you can see the second difference is constant. Now that we have these, I'm going to actually just move it a bit to this side. So it's better to write it a little on that side. Then we're going to look at all the first terms in these patterns that we have. The quadratic, first difference, and second difference. The first terms of these, we're going to equate them to certain things. So you can start from the bottom because it's easier to remember from the bottom. The bottom one, you're going to equate it to 2a. So 2a is equal to 2. And then the first difference, that first term, you say 3a plus b is equal to 7. And then lastly, we say a plus b plus c is equal to -7. And then to find the value of a, we're just going to say that 2a is equal to 2. And to find a, we finally just divide both sides by 2. And so it means that a is equal to 1. And then to find b, it is 3a plus b. But we know that a is 1. So we're going to substitute in place of a 1. Then plus b is equal to 7. Then 3 times 1 is 3. So I'm just going to start with the b. So b is equal to, we still have the 7 here. Since 3 times 1 is 3, we take that 3 over and it becomes a -3. And so b is equal to 4. And then to find c, we just say a plus b plus c. But we already know what a is. It is 1. And we know what b is, so plus 4. And c is equal to -7. Then 4 plus 1 is 5. We'll hold on to that. So c is equal to, we have -7 still. Since that becomes 5, 1 plus 4 is 5. We take the 5 over and it becomes a -5. And so c is equal to -7 minus 5, which is -12. Okay, so now that we have the value of a, b, and c. Remember, they asked for the quadratic number pattern, right? The general formula, the general term. And the formula for the general term of a quadratic pattern is Tn is equal to an squared plus bn plus c. And so let's go ahead and substitute the values of a, b, and c. So Tn is finally equal to, a is 1. So you can say 1n squared, but if it's already 1n, you don't have to say 1n. You can just say n. So n squared, okay, the coefficient of a is 1. Then plus 4n. And then because this is a negative, you don't have to say plus -12. You can just say -12, okay? Because plus -12, when you multiply, it still becomes a -12. And that is our formula. Okay, so that is the first question. It is 4 marks. Moving on to the next question. Okay, so the next question is 3.1.2, which says, which term of the pattern has a value of 128? Okay, so let's pay attention to the question. It says, which term of the pattern has a value of 128? Let's look at our pattern. See, we need to be able to differentiate between what is a term and what is the value of that term. So let's look at, for example, let's look at this -7. The value of this term is -7. But the term, which position is it? It is the first term. Okay, so the term is term 1, but the value of it is -7. If we could look at 9, for example, what is the term number of this? This is the third term, T3, but the value of term 3 is 9. The value of this term is 9. So when they're asking you which term of the pattern has a value of 128, you see which term, they're asking you T what has a value of 128. So we're actually trying to look for the term number. We have been given the term value. Okay, so how do we find this? Well, we're already hearing the language which term, so it has to do with the Tn formula. So we already have our Tn formula. It's Tn is equal to n squared plus 4n minus 12. Okay, so now that we have our formula, what exactly are we supposed to do with this? Well, we're going to have to find out where does 128 go. Since it's a term value, what does it stand for? You'll see that in this formula, we have two things that we need to really focus on. Two things that don't have a value. That is the value of n and the value of Tn. Now, the value of n, it is always going to stand for your terms. That's going to be your terms. And then Tn is speaking about the term value. Okay, we could just call it the value to not confuse. So that would be the value of the term. The reason why is because, for example, if I said, what is the value of term 1? See, in place of n, I have put in 1. That's the term, right? And then if I substitute this, and I'll go ahead and substitute, you would find that when we simplify that, we're finally going to get -7, because that is the value of term 1. So do you see that Tn stands for the value and the n is for the terms? So now using that, we now would know where to put this 128. Since 128 is a value, it would go in place of Tn, because that's our value, 128. And so we'll say 128 is equal to, we have n squared plus 4n minus 12. And then we just have to simplify this. As you can see, you have n squared, you have n, you have a constant. This is a trinomial. So let's go ahead and take 128 over to the right-hand side. So we'll have 0 left here is equal to n squared plus 4n minus 12 minus 128. Okay, so 2 plus 8 is 10. So, and 1 plus that's going to be 30. So 140, that's what we're going to have. So 0 is equal to n squared plus 4n minus 140. Okay, so now that we have this, we have to factorize. So we say 0 is equal to, open up two brackets. You can go ahead and work through it by finding out what would be the factors. You can also do it the quick way as well. So we're looking at n squared. How do we get n squared? By saying n multiplied by n. And then how did we get 140? Well, we need factors of -140. That's going to give us 4. So you can go ahead and work through it and see the factors that you can get. You can also use the quadratic formula, but you're going to have to use it in a way that you don't show them that you have used the quadratic formula, because then you're not really going to, you can't really get a mark for your factors in that part. So what we can do is this. We're going to use the quadratic formula, which is -b, but I know b is 4. So I'm saying -4 plus minus, I'll start with the plus, b squared, and so that's 4 squared, minus 4ac, minus 4, and then a is 1, and c is our constant, which is -140 times -140. And then that is going to go over 2a. A is 1, so over 2 times 1, we didn't even need that. Do you see that the first answer that we get is 10? So please understand how it works. The first answer is 10, meaning the value when we factorize and solve for n is equal to 10. So if n is equal to 10, what would be the factor that you have here? That would be taking 10 over the equal to sign so that you can have n minus 10. You see, because we would have taken n minus 10 and said n minus 10 is equal to 0, then taken that -10 over to get n equals 10. Okay, so please be very careful with this. Don't take this 10 as your factor. It is your answer when you use the quadratic formula. Then we can go or, and to get the other one, you're going to just change that plus to a minus, and we get -14. So remember, that means that n is equal to -14. Well, what is your factor here? N plus 14. And there we go. So that's what we have. You can also deal with it the normal way of actually looking for the factors. That is perfectly fine. But I've also found that this is also another way that you could do that. And I know it's still not factorizing, but it does get you to the answer in ones that do have like big numbers so that you can spend less time on it. Okay, so now we actually have to decide on which one is actually our solution. So looking at this, n is equal to 10 or n is equal to -14. Which would be your answer? It would be n is equal to 10. You have to cancel or invalidate this one, because the thing about it is that the term numbers, they cannot be negative. Remember, the term numbers, they're speaking about positions, like the first term and the second term and the third term. You cannot have the negative 14th term because terms don't move backwards, they only move forward. They work like days, okay? So you can have day 1, day 2, day 3. You cannot have day negative 14. We're not time traveling, so it's not going to work like that. Okay, so this is our solution. N is equal to 10. So the 10 term has a value of 128. And moving on to the next question. Okay, and then we're on 3.1.3, which says, determine between which successive terms in the quadratic number pattern will the first difference be 599. Let's break that. So determine between which, okay, so it's between two numbers, which successive terms. Successive just means that they come after each other. So between which successive terms in the quadratic number pattern. Let me just show you a picture of what's going on here. What's going on is that we have our quadratic pattern, right? It's terms in the quadratic pattern. And the question is just asking, you need to determine between which successive terms, okay? So two terms that come out after each other, it's usually two terms, okay? Because they said, will the first difference be that? For you to have one value as a first difference, it must be between two successive terms, two terms that come right after each other. So determine between which two terms that come right after each other in the quadratic pattern where your first difference is going to be equal to 599. So you see, that's where your first difference is. That's really what they're asking you. So what are these terms? They want to know between which two terms would we have a first difference of 599. Okay, so let me go ahead and bring the pattern down so that we can actually look at this better. Okay, so since we have our pattern, this is our first difference, okay? Remember, the differences of the quadratic pattern is your first difference, and that's our quadratic pattern there. So we need to find out between which two successive terms in the quadratic would the first difference be 599. Okay, so for us to do that, we're going to have to think about it like this. And let me actually write that properly, 599. Since the first difference is 599, how about we find out what term exactly in the first difference has a value of 599? And here's the idea. How we will find this answer is like this. Think about it like this. If we can actually rephrase this question with something that we actually do have here. If I asked you, between which two successive terms in the quadratic pattern will your first difference be 11? What would you say that is? That would be between the third and the fourth term in the quadratic pattern. That's the two successive terms that we have that they come right after each other. Their first difference is 11. So between which two successive terms in the quadratic pattern is the first difference 11? That will be the fourth term and the third term, or third and fourth term, right? So that's exactly how we're going to have to think about that. But I also want you to notice something about this. Do you see that the term 11 in the first difference, this term is the 1, 2, 3, the third term. So the third term of the first difference is between the third term in the quadratic pattern and the fourth term in the quadratic pattern. Likewise, the second term in the first difference is between the second term in the quadratic pattern and the third term. So whatever we get here, the term number, it will be that same term number and then the one after it. Okay, so we can go ahead and find this. We're just going to have to find what term exactly 599 is in the first difference. So for us to find out which term exactly belongs to this in the first difference, we would have to try and find the pattern of this. Okay, the pattern of the first difference. Your first difference in a quadratic pattern, the first difference is always an arithmetic pattern. The formula for an arithmetic pattern is Tn is equal to a plus n minus 1 multiplied by d. And so, in order to find out which term exactly has this value, we're going to go ahead and substitute in here. So, which term has this value? Meaning we're looking for a term number. We're looking for the value of n here. The value that we have is 599. So that's going to be substituted in place of Tn. So that is 599 we put there is equal to A is the value of the first term. This is always going to be the same for arithmetic patterns. So the first term in your arithmetic pattern, in your first difference, that is the 7. So 7 plus, we're looking for n, so n is still empty, n minus 1, multiply by d. D is your difference. We have our constant difference. We know that the constant difference in this pattern is 2. So multiply by 2. And we're just going to solve for n in this. Okay, so to solve for n, let's try taking 7 over. 599 minus 7, I'm just going to already more simplify on screen. So minus 7 is 592. So I take that over, it becomes 592 is equal to n minus 1 multiplied by 2. Now you could distribute, or we could rewrite it like this. This is 2 terms being multiplied by 1 term. You could rewrite it like this: 2 multiplied by n minus 1. That's the same thing we wrote here. And what I'm going to do here is we can get rid of the 2. Since the 2 is being multiplied to this, to get rid of it, you need to divide. And what you do on the one side, you must do on the other side. So what is 592 divided by 2? So take that and divide it by 2, and we get 296. So we have 296 is equal to, that cancels, and we have n minus 1. Then take your negative 1 over, and so you're going to have that n is equal to, when you take it over, it adds a 1 here, so we have 297. So now we know term 297 is this one here, right? If 297 is the term belonging to 599, then between which two consecutive terms in the quadratic pattern would this number lie? That would be term 297 and term 298. So it's going to be like that, okay? Same term and the one after it. So we can conclude, therefore, this is going to be term, you can actually just say it like the way they asked, between which two successive terms. You can say between, it's going to be between term 297 and, I don't have to say term, T297 and T298. That's what your answer is going to be. Okay, and that is it for that question. And we finally move on to 3.2. Okay, 3.2 says, given the quadratic pattern, and then we have the quadratic pattern. They want us to write down the next term of the pattern. Okay, now I want you to notice that this is only for 1 mark. So you don't have to go ahead and start finding the formula of this pattern, okay? The formula of the pattern would score you 4 marks. So that's not what you need to do. So what we're going to do here, since it's only for 1 mark, we're going to do this. First of all, you can find the first difference of this pattern. So 56 minus 29. So we just go ahead and say 56 minus 29, which gives us 27. And then 29 minus 12. So 29 minus 12, that gives us a 17. And then 12 minus 5, which gives us 7. Okay, so this is what we have as our first difference. Then you have to go ahead and find your second difference. So 27 minus 17, that's 10. 17 minus 7, that's 10. So now that we have that, to find that next term, okay, the 5th term in this pattern, what we know here is that our constant difference is always going to be constant. So since it's always going to be constant, we're definitely going to have a 10 here. Now that we have a 10 here, we'll be able to find the 4th term of the first difference by saying 27 plus 10, because this is a positive 10. 27 plus 10 is 37. And now that we know the 4th term of the first difference, we'll be able to find the 5th term of the quadratic pattern by saying the next term, and then this is positive, so plus 37. 56 plus 37. So 56 plus 37, that's going to give you, that's 80. That is a 10 and a 3 left, so 93. So we have 93. Okay, so that is our term. So next term of the pattern, you can go ahead and tell them that the next term is 93. Okay, so that is for 1 mark. Moving on to the next question. Okay, so now we are finally on the last question in question 3. And this question says, we need to show that the first differences of this pattern will always be odd values. Okay, So in the past, I think we've seen questions where they ask us to prove that the first difference is, or not really the first difference, but to prove that a pattern, usually an arithmetic pattern, will always have even terms, okay, or even term values. So for us to prove that something is odd, we're going to have to break it down like this. Okay, for you to prove that something is odd, you have to be able to show them that it's even first of all, and then we added or subtracted an odd number, and then that would make it odd. And this is what I mean. For you to show them, like for example, I can tell you the number 2 is an even number, right? 2 is an even number. To show that something is odd, or to show that 3 is odd, I would have to show you that 3 can be written as 2 plus 1, because we know that 2 is even and 1 is an odd number. If you add an odd number to an even number, you get an odd number. So since they're speaking about the first differences, right, the values of it, let's look at what brings out the values of the first differences. This is our first differences. So first differences, these are our first differences. So since we have those, let's go ahead and find the Tn formula of it, because they want us to show them that they're always going to have odd values. What tells you about the values of these patterns is the Tn formula. So let's go ahead and find that first. So it is the first difference, so it's an arithmetic pattern. The formula for an arithmetic pattern is Tn is equal to A plus n minus 1 multiplied by D. So Tn is equal to, our A value is 7 plus n minus 1 multiplied by our difference, as you can see, is 10. That's the constant difference. Okay, so this is what we have. So for us to show that something is odd, right, I've already explained that you have to kind of show them that it's even and that you added or you subtracted an odd number to this. But how would you prove that something is even? Let me give you an example of this. An even number, by definition, is a number that is divisible by 2 with no remainder. So if you can take a number and divide it by 2 and it doesn't give you any remainder, it's an even number. So if I asked you to prove that 10 is an even number, how would you prove that 10 is an even number? Well, by definition, an even number is a number that is divisible by 2 with no remainder. So I would have to show them that this number can be divided by 2. But I don't necessarily have to divide it by 2, okay? How I can show them that it is divisible by 2 is by taking out a common factor of 2 from here, okay? Or showing them that there's a common factor of 2 here. So how I can do this is by rewriting 10 like this. I can say 10 is made up of 2 multiplied by 5. That is showing you that 10 is an even number because it has a factor of 2, okay? If I say prove that 20 is an even number, then you can say 2 times 10. That proves that it's even because it has a factor of 2. Okay, and we can see no fractions here. So we know that it doesn't have any remainder. Okay, so that is how to show something is an even number. So you get the idea now. We're going to first show them that there's an even part of this, and then we're either adding or subtracting an odd number. Okay, so for us to do this, I would actually like to simplify this a little further. So Tn is equal to, we have 7 plus, and let's distribute that 10. 10 multiplied by n is 10n. 10 multiplied by -1 is -10. So Tn is finally equal to, and we're going to have, I'll write 10n first. Then we have 7 minus 10, which is -3. Okay, so this is our formula. We have to prove to them, show them this formula is odd. Okay, so in order to do that, what I'm going to do is this. But now that I'm thinking about it, I want to be very specific about what it means for something to be odd. Since we know that an even number is a number that is divisible by 2, so it needs to be 2 times something, right? Then for you to create an odd number, you have to show them that you can add, if you can add 1 or subtract 1 from this, then it's going to be odd. I'm trying to take it from the basics. I'm not trying to take numbers like 3 and 5 because I'm going to assume the person looking at this doesn't really know how to prove that something is odd, or to just look at something and say, oh, that's odd. Okay, so I'm going to assume. So I'm going to take it from the basics, and I'm really just trying to say that if you add 1 to 2 or an even number, it's going to become odd. So that's why I'm trying to use 1 instead of other odd numbers like 3 and 5. Okay. So with that being said, let's look at this. 10n minus 3. We first have to show them that this part, there's a part of it that is even. So how do we do that? Well, right now the only even part is this 10n, right? That's the only even part. The 3 is not even yet. So what we can do is, let's rewrite this as Tn is equal to, and we have 10n, and this 3, I'm going to separate it. I'm going to separate a 1 from it so I can show them that it is odd. 1 is very powerful in showing that a number is odd. The same way a 2 is very powerful in showing that a number is even. If you can show something has a factor of 2, it's even. If you can show that an even number, okay, has a 1 being added to it or 1 being subtracted from it, then you've shown them that it's odd. So with this, I'm going to actually separate a 1 from that 3. Remember, it's a minus 3. So to break up minus 3 so that it has a 1 either being added or subtracted from it, you can break it up as minus 2 minus 1. Okay, see, minus 2 minus 1, that gives you minus 3. We have our minus 1. That helps to prove something is odd. Now, at this point, you'll be like, but yeah, this shows them that it's odd because, I mean, this part is even. But that doesn't really prove that it's even yet. Remember, I said that for you to prove that something is even, an even number is a number divisible by 2 without any remainder. So you need to show them that this part is divisible by 2. And how we would do that is like this. So you can tell them that 10n, if you like, I'm just going to actually take it like this and I'm not going to separate the sums. So I'm still going to say 10n minus 2, but what I'm going to do from this is to show them that this part truly is even like I'm claiming it is. I'll take out a common factor of 2 from this part only. So take out a common factor of 2 and you're left with 5n minus 1. That's what you're left with. Then you still have that minus 1 there, right? And now I'm going to try and convince them about something. I'm going to tell them that 2 times 5n minus 1 is even. And I can't say this because it has a factor of 2. It is even for all values of n. So all values of n. So it's even for all values of n, of course, given that n continues to be natural numbers like it's supposed to be, that it continues to be term numbers, okay? Even for all values of n. So if that is even, then it would mean, therefore, that if you have 2 bracket 5n minus 1, that is going to therefore be odd. So is odd. And that is, of course, for all values of n as well. Okay, so now that we have put it like that, I can therefore conclude, therefore it means that Tn, and you can write Tn however you want. You want to write it like this, it's fine. You can write it also like that, it's fine. So I'm just going to write it like this. Therefore, it means that Tn, the fact that I said Tn, I'm still speaking about the values, the first differences values, okay, the Tn pattern. So however I write it is still fine because it's Tn. Tn times 5n minus 1 is odd. And that is our conclusion. We have finally proven that. So you see the most important things. For you to show something is even, show that there's a factor of 2. For you to show that something is odd, show that you have an even, plus or minus or 1. And that will prove it. Okay, so that is it for question 3. And we finally move on to question 4. Okay, so now we're on question 4. And question 4 says, given the linear pattern, and we have 1 minus p, 2p minus 3, and p plus 5, which I have written down here, we have to calculate the value of p. Okay, so please notice that they've given you 3 terms, and they all include p. And you have to find the value of p if this is a linear pattern. Remember, a linear pattern is an arithmetic pattern. So if we remember something about an arithmetic pattern is that an arithmetic pattern has a constant difference, okay? The difference is always exactly the same. And that's what we're going to use to actually find the value of p. So we're going to find the difference between each term. So we're going to start with the third term. Say the third term minus the second term. And let's see what we get. That is p plus 5 minus 2p minus 3. Now notice there are 2 terms here. So in order to protect that so that it really does subtract by 2p and minus 3, you need to put a bracket. So 2p minus 3. And then you need to say the second term minus the first term, which is 2p minus 3 minus, again, you have two terms, so protect it with brackets, 1 minus p. And now that you have the differences, you see this is a second difference and another second difference. What we know about a linear pattern is that the second difference is constant. So since it is constant, it means that this second difference is going to be exactly the same thing as that second difference. So what we can do is equate them, say that they are equal. And now we just have to solve for p. So let's go ahead and distribute. So we have 2p minus 3, distribute that, that is minus 1, and plus p is equal to p plus 5, distribute minus 2p and plus 3. Okay, so I'm going to add the p's first. That gives us 3p, negative 3 minus 1 is negative 4, is equal to, and p minus 2 is negative p, and we have 5 plus 3 giving us positive 8. So I'll just put it as 8 minus p. And then put your p's together. So we have 3p, we're taking that over, it becomes a positive p, so now we have 4p here. Is equal to, we have 8 here, taking this negative 4 over, and so it becomes a plus 4, giving us a 12. So 4p equals 12, we divide both sides by 4, and so therefore p is finally equal to 12 divided by 4 is 3. And that's our value of p. Okay, so that is for 3 marks. Moving on to the next question. And now 4.2.1 says, write down the value of the first term of the pattern. So the first term of the pattern, as you can see, is 1 minus p. So I'm just going to say t1 is equal to 1 minus p. But now we know what p is. P is 3. So t1 is actually equal to 1 minus 3, which t1 therefore now gives us negative 2. And that is for 1 mark. Moving on to the next question. And then 4.2.2 says we need to write down the value of the common difference. So the common difference, now we can actually easily find that by just taking one of these, because remember, that's the common difference or constant difference, the same thing. So we could take this and then substitute p back in. But I'm just trying to look for a quicker way to do that. And I think the quickest way is, why don't we just look at the fact, yeah, that is actually the quickest way, but you're going to have to take the simplified version of it when you didn't take anything over. So do you see that when we said T2 or term 2 minus term 1, that gave us our common difference, right? And we took that, we simplified it, and we got it to this point. So I can take this part because this is the common difference, and I can just substitute p back in. So 3p minus 4. I can say d is equal to 3p minus 4 and substitute 3 back in. So 3 times 3, because that's the value of p, minus 4. 3 times 3 is 9 minus 4, which is 5. And so there we go. We have our difference being 5. Moving on to the next question. Okay, so now we're on the last question, 4.3. And 4.3 says, explain why none of the numbers in this linear pattern are perfect squares. Okay, so why none of the numbers in this pattern are perfect squares? So we're going to just have to fill in what these are. So I'm going to go ahead and just fill in it so that we can just get the pattern. I don't think we have to write this out, but I mean, we can. Let's just go ahead and do that. So 1, and then we know p is 3. So 1 minus 3, 2 times 3 minus 3, and 3 plus 5. So 1 minus 3, that gives us negative 2. And then 2 times 3 is 6 minus 3, which is 3. And then 3 plus 5 is 8. So this is the pattern. And they want us to explain why none of the numbers, so they say none of the numbers in this linear pattern are perfect squares. Okay, so I'm looking at this and I find it weird. Why are they saying none of the numbers? So basically, if we keep continuing, we're never going to find a perfect square. That's what they're saying. So I would like to actually find out whether that's true or not. So let me go ahead and see. We know that every single time, right, we found our difference is 5. We keep adding 5. So I'm going to continue this pattern and I'm actually going to check whether it's true. Does it really never have a perfect square? And doing this is very good to actually do stuff like that because it helps you understand more about the pattern and sometimes even leads to the answer. So I'm actually going to do that. Let me go ahead and keep adding. I know I kept adding 5, right, to get the next term. So I'll keep adding. So if I add 5, 8 plus 5, I'll get 13. If I add plus 5 again, so plus 5, I'm going to get 18. Plus 5, I'm going to get 23. plus 5. I'm going to get 28 plus 5. These numbers look very similar. Keep adding 5. Then we have 33. Okay, I'll add 5 again. Then we have 38. You see that there's a pattern with these numbers. So the whole argument here, remember, was I'm looking at this, and since they said that we need to explain why these numbers will never be a perfect square, I wanted to actually see whether this was true, whether they would actually never be a perfect square. And if you look throughout all these numbers, there is no perfect square. We don't have a perfect square, even if you keep going, right? But I see no need to keep going because you can already see how this keeps ending. Do you see that there's a similarity between all these numbers? What do you notice is happening throughout all these numbers? Except for the -2, of course. So you have a 3, then an 8. Then you have a 13, which ends with 3. Then an 18, which ends with 8. And 23 ends with 3. 28 ends with 8. Again, ending with 3, ending with 8. These numbers, as we keep going, and I would love to continue, but I'm just seeing that, yes, as we keep adding, it keeps ending with 3 and 8. That's what keeps happening. Ends always with 3 and 8. And we can see that there's absolutely no perfect square. So let's think about that. Why are these numbers not perfect squares? Well, for us to see that, we're going to have to understand what perfect squares look like. So I'm going to list down perfect squares, and let's actually look at perfect squares and look at these numbers and then try to understand why these ones never end with perfect squares. These ones that continuously end with 3 and 8, why are they not ending with perfect squares? Okay, so let's look at perfect squares. Perfect squares you can find by saying 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is 9. 4 squared is 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. Let's start with, let's say 13. 13 squared, 169. Okay, so let's look at these numbers and see why do we not have any perfect square here? What's the difference between the perfect squares and these ones? Okay, so I'm going to look at these numbers and just see. So first one, the first number is 1, and then we have 4, and then we have 9, we have 16, right? Since these ones, we noticed the pattern was that these numbers, they kept ending with 3 and 8, right? Perfect squares, because for it to be a perfect square, it's going to have to end with a number that a perfect square would normally end in. So looking at the perfect squares, this perfect square ends with 6 and this one 5, right? So first, we're already seeing, right? This first perfect square ends with 1, then 4, then 9, then 6, none of which are 3 and 8. Also, just notice that. Then this one ends with 6 again. Okay, so we already had a perfect square that ended with 6. So we can see there's a pattern here. Perfect square numbers, it's very possible that a number is a perfect square if it ends with 6. Let's keep that in mind. Keep going. So 49, you see it ends with a 9. So it's very possible for you to have a number that is a perfect square, right? If it ends with a 9. So if a number ends with 9, there is a chance that it could be a perfect square. So there we see another repetition going on. Perfect square numbers end with 9, with 6, with 5. Well, we have to see if there's a pattern. If we keep going, we will see that. I see again 64, that ends with 4. So perfect square number can also end with 4. 81, we already have 1. So perfect square numbers can also end with 1. 100, that is a new one. Perfect square number ending with 0. Then we have 121 also ending with 1. 144 ending with 4. 169 ending with 9. So the only thing I'm not seeing really a repetition is with the 5. But then again, I think about it and I remember that 225 is a perfect square and that ends with 5. So with this, we can actually conclude 0. That's an easy one. Definitely, you will have a perfect square that also ends with 0. For example, 20 times 20 is 400. So that ends with 0. So now do you realize that with a perfect square number, perfect square numbers, they end with, or let's just say this is what they end with. They end with numbers like 1, 4, 9, 6, 5. Then we have 6 again, 9, 4, 1. We already have that 0, right? And that's basically it. Those are the kind of numbers that perfect square numbers end with. We can keep going just to check if there's any other. And let me just go ahead and check. Okay, so there definitely can't be any other number that it ends with, because if you look at it in an ascending order, so it's like 1 and 4. We also have 5, we have 6, we have 9. We know that perfect square numbers don't end with 7. We can't really have a perfect square number that ends with 7. So definitely these are the numbers. We can put them in their proper order. So it will be 0 first, then 1, then 4, then 5, 6, and 9. Perfect square numbers end with this. But these numbers that we had in the beginning, that pattern that we had, they are ending with 3 and 8. And we can see now the pattern with perfect square numbers, they only end with these numbers. And you can continue going with perfect squares and check whether they end with anything else, but it's really only these. So the reason you will never ever get a perfect square here is because, well, other than this first term, it's not a perfect square either, but this first term ends with 2, not 3 and 8. But other than that, the reason we would never get a perfect square here is because perfect square numbers end with 1, 4, 5, 6, and 9, right? And 0, of course. While these numbers, except for the first term, they're ending with 3 and 8. So this is something that you just have to look at. It has to be by observation. And it's worth 2 marks. I really don't think it would have taken somebody 2 minutes to think of that. I mean, it is possible. But okay, that is really the conclusion. You can just conclude it. So the reason, and I'll just write the reason down and then read it out. Okay, so this is my conclusion. So apart from the first term, the linear patterns term values all end with 3 and 8, as we saw, apart from the first term, which because that one is 2, but everything else ends with 3 and 8. But perfect square values end with these numbers 0, 1, 4, 5, 6, and 9. So this would mean that none of the numbers in the linear pattern will be perfect squares. So that will be the reason for that. Okay, so that is question 4.3, and that is the end of question 4, which is 7 marks. And we finally move on to question 5. Okay, so now we are on question 5. And question 5 says, the graphs of f of x is equal to ax squared plus bx plus c, so it's just a parabola, where a is not equal to 0, and g of x is equal to 6x plus k, so that's the straight line we have there. We have the gradient. They say that they are drawn below. So point D is 1 and -8 is a common point on F and G. Then we have F intersects the x-axis at -3 and 0 and 2 and 0. So these are the x-intercepts of the graph of F. Then G intercepts the graph of F at point D only. So it intersects here at one place only. So here are the questions we have. The first question is 5.1. For which values of x will f of x be less than or equal to 0? Okay, so with the inequalities that we worked on in question 1, where we dealt with the graph method, you would know how to work through this. Remember that you have your x-intercepts. That is -3 and 2. Now remember, it's asking for where f of x, this graph, is less than or equal to 0. But please remember that f of x stands for y, right? So it's really asking for the y values of f. Where are the y values of f going to be either less than or equal to 0? Where they are equal to 0 would be at the x-intercept, because at the x-intercept, x has a value, but y is equal to 0. So at the x-intercept, that's where it's equal to 0. But where is it less than 0? So again, if you look at the graph, if you look at maybe this top part, look at the y values, because we're trying to look at the y values of f. Where are they going to be less than 0? So here are the y values of f. Look at them. Look at these y values. What would you say these y values are? Are they less than 0 or greater than 0? They will be greater than 0. So every part of the graph that is above the x-axis, it will have a y value that is greater than 0. See, all of these are positive y values. So we're not going to look at that. We're looking for where f of x is less than 0. We already know where it's equal to 0. So where it's less than 0 would be every part of the graph that is below the x-axis. So now that we know that, what are these x values? What are the x values belonging to this? Well, if I line this up to the x-axis, if I look at these values, so looking at it versus -3, compared to -3, these are values that are moving to the right-hand side of -3. And the numbers on the right of -3, these are numbers that are greater than -3. So it's going that way. So if you look at it, it's really just where x is greater than -3, but not just greater or equal to -3, because at -3 you have a y value being equal to 0, and we're looking for where f of x is less than or equal to 0. Okay, so that's the -3 part. Or the 2 part, as you can see, the y values are moving on this side. So these are values that are what than 2? These are values that are less than 2. Okay, so that's where x is less than or equal to 2. Same reason why, okay? Then do you see that they are pointing towards each other? So there is a relation. And so we can write it together. Therefore, if we're writing it together, remember, put x in the middle. The smaller number rather is here, -3. The bigger number is here. So we're saying that, as you can see, the inequality is facing the x. So x is greater than or equal to -3. Here the inequality is facing the 2, but less than or equal to 2. And that will be your answer, and that is for 1 mark. Moving on to the next question. Okay, so question 5.2 says, determine the values of A, B, and C. So what are the values of A, B, and C? Let's look at that. Well, you see, that is the remaining parts, or really what will help you complete the formula of F. So A, B, and C. Let's look at the graph. Let's look at what they gave us. In this parabola, to find the formula of the parabola, right, you can see that they've given you 2 intercepts and 1 other point. When you're going through your notes on how to actually find the equation of a parabola, there are about like 3 ways. And one of the ways includes when they give you x-intercepts. So they give you 2 x-intercepts and 1 other point, or 2 x-intercepts and the value of A, you're going to use the x-intercept formula. And that looks like this. So in this case, we're speaking about f of x. So f of x is equal to, you're going to say A, and A is literally just that first value there. It's the same thing as A here, okay? It's A multiplied by x minus x1 multiplied by x minus x2. Okay, so let me speak about what x1 and x2 stand for. See, the x1 and the x2 here, they just stand for your intercepts. Okay, so that's the first and the second intercepts, x-intercepts really. So with that, we know what they are. We already know that the first one, x1, is -3, x2 is 2. So we're going to substitute. So we have f of x, you first substitute the x-intercept. It's equal to a bracket x minus, the first x-intercept is -3, so that's minus -3, which if you multiply will become +3. And then x minus the 2, right, which you just say -2. Okay, so now that we have this, we have A, we just still need to find A really. To find A, what you're going to do is, we've used the x-intercept, we just have to use the other point. So we're going to use that other point D. Okay, I also just noticed now that this 8 is not +8, is a -8. So that's a -8. So we can go ahead and substitute it into this formula that we have here. So that is going to be the y value is -8. -8 is equal to, then we have A multiplied by, and substituting we have 1 plus 3. 1 is our x value, and then 1 minus 2. Okay, so this is -8 is equal to, we have A, 1 plus 3 is 4, 1 minus 2 is -1. So if you say 4 times -1, you get -4. Now to solve for a, you just get rid of the 4, the negative 4. It's been multiplied, so you have to divide to get rid of it. Divide both sides by negative 4. And so a is finally just equal to negative 8 divided by negative 4 is positive 2. So we have a. How do we find b and c? Well, this is our equation. You see this? This is the only thing that has just one thing missing. It has a missing. So we're going to substitute it back into that equation to find b and c. So that is f of x being equal to, and we have 2 multiplied by x plus 3 multiplied by x minus 2. And now that we have this, to find b and c, do you remember that f of x is in standard form? It's in the form of ax squared plus bx plus c. So it means that we need to put this in standard form. So to put it in standard form, we say f of x is therefore equal to 2, and then we're going to distribute these two. So multiplying it out, it's going to be x squared minus 2x plus 3x minus 6, right? And of course, if you simplify that, because these two can actually add, negative 2 plus 3 is like 3 minus 2, which is 1. So that's going to be a positive x in the middle that we have there. And then we have minus 6 still. So I'm just simplifying that on screen. So f of x is equal to, and let's distribute. We have 2x squared. We multiply that in, that's plus 2x. Multiply that in, that's minus 6. Minus 12, sorry. Minus 12. Okay, so now that we have this, we can finally see what a, b, and c is. Since it was in the form of ax squared plus bx plus c, it means therefore that a is equal to 2. B is equal to 2, and C is equal to negative 12. And that is the answer for 5.2, the value of A, B, and C. Moving on to the next question. Okay, 5.3 says we need to determine the coordinates of the turning point of F. Okay, so with the way they phrased this question, the fact that it's 3 marks, I can actually see 2 methods of doing this. It's 2 methods really because there are 2 ways of finding the x value of the turning point. But the y value, we find it the exact same way. So I just want to show you 2 methods. Okay, so the first method, we're going to look at the graph. Okay, so to find that, remember, the turning point is right in the middle of the graph. So if you drew a line, a vertical line like this, which is actually the axis of symmetry, this line is going to be right at the center. So it means that to find the x value of the turning point, what you could have done is you could have used the x-intercepts. So you see these 2 x-intercepts. If we find their middle, like the middle value of these, that x value is going to be the x value belonging to our turning point. So we can actually do that. And because I said the middle value or the middle point, that's really trying to find the midpoint. So I'm going to find the midpoint of these 2 x values of x1 and x2. So to find that x value of the turning point, I can say x is equal to, and I'll say it's x1 plus x2 over 2, right? So that is going to be our negative 3 plus 2 over 2. So we're going to substitute negative 3 plus 2 over 2, and negative 3 plus 2 is negative 1. So it means that x is equal to negative 1 over 2. That's the x value, okay? That's just one way of finding the x value. And then to find the y value, you would take the x value that you got, the middle of that, because it's the middle of the x value, and you would substitute it into the equation of this parabola to find its corresponding y value. So let's do that. So the negative a half. Let's go ahead and take the equation. The equation we have is, the final equation is this. So I'm going to substitute it into that. So that is f of negative 1 over 2 is equal to, and we have positive 2 bracket negative 1 over 2 all squared plus 2 bracket negative 1 over 2, right? And then c is negative 12. So minus 12. Minus 12. And let's see what we get. Okay, and we get negative 12.5 as a fraction. That is negative 25 over 2. So f of negative 1 over 2 is equal to negative 25 over 2. Okay, so that would mean that your turning point, right, it doesn't have a coordinate. It's just the turning point. So the turning point is negative a half and negative 25 over 2. Okay, so remember, that's just method one. That's just one way of finding the x value of the turning point. You would still get your mark because you would get a mark for finding that x value, for substituting and getting your final answer. Okay, so it'll still be 3 marks. Then if you wanted to use the other method where we use the equation of the graph, we could have done this. So you could have taken your equation, f of x is equal to 2x squared plus 2x minus 12. And you could, using this equation, you could find the x value of the turning point by using this formula. The formula to find the x value of the turning point is the formula for your axis of symmetry of your parabola, which is x is equal to negative b over 2a. Okay, so x is actually equal to negative, what is our b value? It's 2. So negative 2 over 2, and our a value is 2, multiplied by 2. As you can see, that's 4 on there, and that's 2. So negative 2 over 4 is really just negative a half again. Then to find the y value, you'd have substituted that negative a half into that, get a mark for your substitution, and you would get negative 25 over 2 again, still leading you to the exact same answer. So that's what I meant by it's not really a method 2, it's just a different way of finding the x value of the turning point. So you could use the x-intercepts, or you could just use this formula to find it. Okay, so that is it for this question. Moving on to the next question. Okay, so 5.4 says, write down the equation of the axis of symmetry. So the axis of symmetry of h, if h of x is equal to f of x minus 7 plus 2. Please notice that is only for 1 mark. Okay, so for you to do this, it may actually seem complicated, but it's actually a very simple thing. You have to think about it like this. You see, h came from f. Right? We took f and we translated it and gave us h. So if you can think about, you can find what the old axis of symmetry was, meaning the axis of symmetry for f. If you can find that, then you can find the new axis of symmetry by applying the translation that happened. So let's go ahead and look for the old axis of symmetry. And I actually did mention this. Remember when I was speaking about finding that x value of the turning point? I mentioned that that is the line that is right in between the parabola, which is also the axis of symmetry of the parabola. So that equation that you got there, right, that x is equal to negative 1 over 2, that is your axis of symmetry. So remember, if they ever ask you find the axis of symmetry of a parabola, you know the equation is x is equal to negative b over 2a. And if you do that, you just say x is equal to, substitute your b and your a, and that's your answer. Okay, so since we already have the axis of symmetry of f, axis of symmetry of f is this, right? X is equal to negative 1 over 2. How do we find the axis of symmetry of h? Well, we would have to know how did we get from f to h. As you can see, they said f of x minus 7 plus 2. That's how we got to h. That's what we must do to get to h. So let's try and understand what this translation is. What does it mean? So this translation says x minus 7, meaning where we see x, we subtract 7 from it. Okay. Now, what does that actually mean? You have to actually translate it in words first for you to understand how it's going to affect that graph, that line, that vertical line that we had there. Whenever you see x minus 7, f of x minus 7, right? This is actually saying that this graph, let's just think about it like this on a Cartesian plane, because I don't want to just say things and then we can't see why it's happening. When you say f of x minus 7 on a graph, when you're trying to, or in an equation, when you're trying to translate it into a graph, what it's actually saying is we're going to focus on the x, right? And we're going to subtract 7. Subtracting 7 from the x means something. Remember x values, right? These are values here. These are all these values here. You would notice that x values, they control the left and the right movements. Because if you had a value over here, like, right? Let's just say we had 3 and 2. Okay. We have 3 and 2 there. And I said we are going to move 2 units to the right. So from here, move 2 units to the right. We'll just go from here and move 1, 2. What's your new point? Well, only move 2 units to the right, which, as you can see, if you're moving to the right, this new point, this was 3 before, this is now going to be 5. So do you see that this is now 5 and the y value change? No. So that's what I meant by the x values. They really control the left and the right movements. So the minute you're saying x minus 7 as an equation, okay, f of x minus 7, it means something is happening with the x. Something is moving either left or right. If it says minus 7, please note it's actually moving to the right. It's 7 units to the right. If it says plus 7, it's moving to the left. Okay, this is because this is the equation. That's the difference between what the equation looks like and what the actual translation on the graph looks like. Okay, so we know that it moves 7 units to the right. Then, do you see that after the f of x minus 7, right, which is really your f of x, you have a plus 2. When you have a plus 2 there, because f of x minus 7, it's actually speaking about a y value now, right? When we translate the x, and you're saying plus 2, it means that we're taking our y value and we're adding 2 to it. The y value, so if we're adding a 2 to the y values on a Cartesian plane, they control the up and down movements. If you have a plus 2, there's no confusion in this one. Plus 2 really just means that the graph is moving 2 units up. So 2 units up. Let me just say 2u up, right? That's all it means. If it has a minus, it's moving down. So since we know this now, we know the translation. This graph just moves 7 units to the right and 2 units up. We just have to think about what the new equation of the axis of symmetry is going to be. Now you have to take note that the axis of symmetry is literally just an x value. It's a vertical line. Okay, so if you had that vertical line of x being equal to -1/2, and now we know that it's supposed to move the new graph, okay, of h. Moved 7 units to the right and 2 units up. Think about how this is going to look. If this moves 7 units to the right, it's at -1/2. 7 units to the right moves this way. So you're just going to go from -1/2. You just need to add 7. Then you get your new graph. So your new graph is going to look like x is equal to -1/2 plus 7, right? And so that's going to be 7 and that's 7 minus 1/2, which is 6.5, which as a fraction would be 13/2. So you can either say 6.5 or 13/2, it's fine. That would be the new equation. Think about it. If you take this graph and you move it up, it's not really gonna move because it's already a vertical line. It's like picking up a vertical line and trying to move it up. Well, guess what? The equation is still exactly the same because it's still passing the same x value. It's a vertical line. So the equation still stays the same. The equation is just going to stay like that. So really, if you write in calculation-wise, all you'd have written is x is equal to -1/2 plus 7. And so therefore, x is equal to 13/2 or 6.5. It's fine. Okay, and that will be your answer. So it's only for 1 mark. Okay, so I just explained in more detail just so that you'd understand what's going on there. Moving on to the next question. Okay, then we are on the last question in question 5, which is 5.5, and it says, determine the equation of a line Q, which is perpendicular to G, passing through the points -3 and 0 in the form of y is equal to mx plus c. Okay, so they're just saying that you need to find the equation of a line, and the name of the line is Q. But Q happens to be perpendicular to G, and it passes through the point -3 and 0. And we need to just write the equation in the form of this. So to do that, I'm actually just going to get that graph. I'm going to get this because that's going to be very important just for us to visualize what's going on. So I'm going to paste this here and let's go ahead and figure out what this line Q looks like. So we need to find the equation of that line, and its name is Q, but it is perpendicular to G and it passes through the point -3 and 0. So it's going to be perpendicular to G, but it also needs to pass through that point. So it's going to look something like this. Let me actually just move that. Something like that. And then it just passes through like that. Okay. And it's perpendicular to G. So this is G. Remember the straight line. This is our line Q that they're speaking about. We need to find the equation of this line if it is perpendicular to G and passes through this point -3 and 0. Okay, So how do we do that? Well, in order to find the equation of this line Q, you need to remember that it's still a line. It's still a straight line. The equation of a straight line, like they've given you here, is y equals mx plus c, meaning you just need to find your m and your c. So we can start off with the m. How do we find the gradient of Q? Well, because they never told us that it passes through D. Yes, my construction may pass through D, but they never told us that. So I'm not going to assume that it passes through D. What I'm going to do is instead, I'm going to try to find the gradient of this using anything else that they gave me. Let's go ahead and look at the scenario. If you look at the scenario, you will notice that they told us that g of x was equal to 6x plus k. So we don't know what k is, but we do know what the gradient is. We know the gradient is 6. I'm going to hold on to that. Since we know that g of x is 6x plus k, so that is 6x plus k, our gradient is 6. To find the gradient of this line, you're going to have to remember that these two lines are perpendicular. So if two lines are perpendicular, this is how the gradients would work. The gradient of the first line multiplied by the gradient of the second line would give you -1. So it means that the gradient of this one, right, if I like and call that m of q, right, gradient of the q multiplied by the gradient of g, and I'm actually just going to leave it like that, multiplied by gradient of g. Now the gradient of g, we already know it's 6. That is going to give you -1. We can use this equation to find the gradient of q. So the gradient of q, to find that, you just have to get rid of the 6. The 6 is being multiplied to the q, so in order to get rid of it, you need to divide by the 6. Okay, so we divide both sides by 6. And so it means that the gradient of q is finally just equal to -1 over 6. Now that we have the gradient, we can focus on finding the y-intercept. So we can just use the equation of the straight line they gave us. Since they already gave us y is equal to mx plus c, let's use that. So we're saying y is equal to, our m is -1 over 6, -1 over 6, x plus c, right? To find c, you see that if you have a point that you can put in place of x and y, it will form an equation where you can find c. So remember the points they gave us, they said that it passes through that line, right? Passes through the points -3 and 0. So let's go ahead and use that. So we're going to use -3 and 0. We're going to substitute -3 and 0. So this is our x, this is our y. So we're saying 0 equals -1 over 6 multiplied by -3 plus c. If you multiply these two together, negative times negative is a positive. 3 times 1 over 6 is 3 over 6, which is really just 1 over 2. So 0 is equal to 1 over 2 plus c, and then take 1 over 2 over to leave c on its own. And so it means that c is equal to -1 over 2. And therefore, the equation of q in the form of y is equal to is y equals the -1 over 6x plus -1/2, which is just -1/2. And that is the equation that we have there. That's the equation of q. Okay, so that is the final answer. That's the last question in question 5. And then we finally move on to question 6, which has more functions. Okay, so now we're on question 6, and question 6 says, given p of x is equal to 4 to the power of x, and h of x is equal to 2 multiplied by x minus 1 all squared minus 8. You need to sketch the graphs of p and h on the same set of axes in your answer book. So indicate all intercepts with the axes and any turning points. So I don't really have the answer book, so we're just going to have to do this with the page that we have here. Okay, so first of all, before even sketching, let's just label the kind of graphs that we have here. You see, you have p of x is equal to 4 to the power of x. You see where x is? It is on the exponent. So it means that this is an exponential function. And then you see this graph h of x is equal to 2 bracket x minus 1 all squared. When you distribute, the x is going to be squared, meaning the highest exponent of x you're going to have is going to be a 2. Really just mean you're going to have an x squared. when you have an x squared and the 2 is the highest exponent, it's a parabola. So this is a parabola, and as you can see, it is a parabola that is in turning point form. Okay, I'll just say TP form. It's in turning point form. So let's just keep that in mind. So we just need to draw these two graphs. Okay, so let's just figure out certain things that we need to find in order to draw these two graphs. So I'll put them separately. We will speak about how to sketch the parabola here, and on this side, how to sketch the exponential function. Okay, so with the parabola, I just go through, I use these steps. They're very similar. The first step is I think about the shape of the parabola. The shape of this parabola, you have to look at the value of a to find this. So the value of a, since this is in the form of a times x minus p all squared plus q, a is positive 2. So it means that your parabola is going to be, since it's greater than 0, it's going to be a smiley face parabola. Okay, and then the second thing I think about is the turning point. Now, this is amazingly already in turning point form. So to find the turning point, it's really simple. You're just going to look at the P and the Q. P and Q are your turning points. Please notice I said positive P and then Q, meaning whatever Q is. It says minus P here. So if you see minus 1 here, then your P value just needs to, you just need to change the sign really. Okay, since here we had minus P, but here we have P. So it means here your P value is 1. And your Q value, as you can see, positive Q, we still have a positive Q, it stays the same, so it's negative 8. So there, we got the shape, the turning point. Then the third thing you look for is y-intercept. Okay, I start with the y-intercept because just get that out of the way, then x-intercept. So in this case, the y-intercept is not negative 8. You can't just look at the last term and say, oh, that's negative 8. And the thing is, the reason you can't do that right now is because this is in turning point form. If it was in standard form, you can do that. Because it looks like that, to find the y-intercept, you have to just make x equal to 0. So let's go ahead and do that. We're making x equal to 0 in h of x. So instead of h of x, I'll say h of 0 is equal to 2 times, I see x, substitute 0 minus 1 all squared minus 8. 0 minus 1 is 1, negative 1 I mean. Negative 1 all squared is 1. 2 times negative 1 is 2. 2 minus 8 is negative 6. So h of 0 is negative 6. That's what we have. So our y-intercept as a coordinate, the x value is 0, y value is negative 6. Then we need to find the x-intercept. So number 4, x-intercept, x-int, the y value must be 0. So to find the x-intercept, let's just make y equal to 0. So I'll say h of x, instead of h of x, I say 0 is equal to 2 times x minus 1 all squared minus 8. Okay, making y equal to 0. Then we're just going to say, we can go ahead and take 8 over. Okay, so take 8 over becomes positive 8 is equal to 2 times x minus 1 all squared. Then, to get rid of the 2 so that we can get into the x, divide both sides by 2. And so that gives you 4 is equal to x minus 1 all squared. Okay, so this is a different way I'm dealing with it. I'm not distributing and simplifying, then solving for x. I'm doing it this way. Then, to solve for x, I'm going to try to get rid of the squared because it's the only thing stopping me from getting into the x right now. So, to get rid of the squared, you need to square root both sides. But because this is an equation, when you're square rooting both sides, you need to remember to add a plus and a minus by the number, the thing that doesn't have x. And so it means you have plus minus the square root of 4 is 2 is equal to x minus 1 because that breaks open. And now we can leave x on its own and take the 1 over. This is a negative 1. It comes over and becomes a positive 1. And we still have plus minus 2. Right? So it's 1 plus minus 2 is equal to x. Now you can share it. Say x is either equal to 1. Then you can take the plus first, plus 2. Or x is equal to, again, 1. Then take the minus, minus 2. And so that means x is either equal to 3 or x is equal to negative 1. So that's another way of working it out. If you didn't want to factorize it, and this works best if it is in turning point form. Okay, so those are our x-intercepts. As coordinates, of course, it's 3 and 0. The other one is negative 1 and 0. Okay, so we have our important points now in the parabola. And now we have to do the same for the other graph. So our other graph is the exponential function. Let's go ahead and draw that down. So the exponential function, I use a similar steps really. The first thing I think about is also the shape of the graph. Because our exponential function says 4 to the power of x, this is what we're going to have to think about. It's just 4 to the power of x, meaning because we have, well, let me show you what the exponential function looks like, the general form of it. The exponential function is in the form of a multiplied by b, which is your base, to the power of x minus p plus q. Now, I don't have to explain every single thing here. It's not really necessary because we just have a 4 to the power of x. Just notice that the 4, right? The base is whatever number is carrying the exponent. The exponent in this case is x, so it makes your base 4. So in this case, the a value is the number in front of 4, and we can see there's no number there, so it's actually an invisible 1. So since a is equal to 1, all this means is if a, right, if you have an a value that is greater than 0, meaning it's positive, right? So if our a value is positive, all this means is we're just going to look at whether it's going to your graph, it's going to have an asymptote, and you're going to think about whether it's going to lie above the asymptote or below the asymptote. If a is greater than 0, your graph is going to lie above the asymptote. So that's not the full story about the shape of the graph. The second thing to note is what the value of b is. If b is greater than 1, so at the same time, if b is a value that is greater than 1, then it means that your graph is going to increase. So together, they kind of give you the shape of this graph. The exponential function, it has an asymptote, and it's above the asymptote, and then it's also going to be increasing because as you can see, our base is greater than 1. So our graph is going to do that. Now, I know it's like, do I have to study all of these? No, not really. All you have to study is the a part. If you know that a is positive, if a is positive, it's above the asymptote. If a is negative, it's below the asymptote. To find out whether it's increasing or decreasing, you don't have to study all of these. All you have to do is this. Take your graph, right? It's p of x is equal to 4 to the power of x. To find out whether it's increasing or decreasing, just substitute two x values. They come right after each other. So let me make an example. I can substitute x is equal to 1 and x is equal to 2. And I'll just check what the y values of those are. So when I substitute 1, what do I get? 4 to the power of 1 is 4. Then when I substitute 2, 4 to the power of 2 is 16. Then you're just going to look at your result. Look at 4 and 16, right? From x being equal to 1 to x being equal to 2. Would you say the numbers are increasing or decreasing? They are increasing. So there we go. And that's how you know that this graph is increasing. You don't have to study that whole thing. I know it's in textbooks. It's not really necessary. You can study it for understanding's sake, but for exam's sake, it's not really that necessary when you're sketching graphs. Okay, so we know it's increasing. We know what it looks like now, in fact. Okay, so it looks like that little sketch that I just made there. You still have to find some important things here. Now, there's another thing about this graph. Remember, it lies on a Cartesian plane, right? So we're going to have a y-axis for sure and an x-axis. Now, the thing about the x-axis is sometimes this graph is like this. For example, let's say the x-axis is here. If the x-axis was here, it means that this graph will never cut the x-axis. But if the x-axis was here, then it's going to cut the x-axis eventually. And that would mean you would have an x-intercept. So it is important for you to actually decide beforehand whether your graph is going to have an x-intercept or not. And we will find out whether it will have an x-intercept using its asymptote. Now, the asymptote is the value of q. That is your asymptote. I'll just call it an asymp. Okay, asympt. And then that, how do we find that? That is whatever is being added to your exponential function. We just have 4 to the power of x and we have nothing. So it means that the value of your asymptote q is actually equal to 0. So here's the thing about finding out whether it actually has an x-intercept or not. If you have your graph, right, And let me actually just say it like this. So if you have a graph and your asymptote is greater than 0, right? Meaning numbers like 1, 2, 3. If your asymptote is up there, let's say your asymptote was just by 1, then by default, if your graph is above the asymptote and increasing, then your graph looks like this. And so, as you can see in this situation, this graph will not have an x-intercept. So if your asymptote is greater than 0, you will have no x-intercept. I'm just putting these so that you can remember them with exponential functions. And so that would mean that if your graph, and let me actually just be exact with that. This is if q is greater or equal to 0, you will have no x-intercept. And let me explain why with the where q is equal to 0. You see, if this is q is equal to 0, it means that your x-axis itself, your asymptote actually lies on the x-axis. That's what it would mean. So if your graph is here, since the asymptote is on the x-axis and the graph will never ever touch the asymptote, it will never intersect the x-axis and it will never have an x-intercept. So in this case as well, it also wouldn't. Okay, so if it's greater or equal to 0, no x-intercept. However, if your graph, if your asymptote is less than 0, you will have an x-intercept. Okay, so that's something you can actually just think about so that you know already beforehand whether you should think about including an x-intercept or not. So that means I'm not even going to bother looking for an x-intercept. I'm going to go straight into looking for a y-intercept because our q value is 0. As we can see, there's nothing here being added, so it's 0. So it means that q is equal to 0, there is no x-intercept. I only have to look for a y-intercept. That's all I'm going to do. So delete that. I'm going to look for a y-intercept only. Y-intercept, so here I just needed the shape and the y-intercept. To find the y-intercept, always you make x equal to 0. So take your equation, p of x is equal to 4 to the power of x, make x equal to 0, p of 0 equals 4 to the power of 0, and p of 0 is equal to 1. So there, your y-intercept is 0 and 1. Okay, so there we have everything we need to actually sketch our graphs. We just have to sketch them down now. Okay, so I just drew a quick Cartesian plane. To sketch the graphs, I actually want us to start with the exponential because I feel like it's easier to draw. With the exponential graph, you just have to first draw the asymptote. So let's draw that asymptote first. We know, well, we know where it is. It's here. If you like, because even if you drew it on a dotted line, it won't show, okay? Because you're using a pencil. So just show them that you have that asymptote there. And I know I called it q, right? But as an equation, it's actually going to be y is equal to 0. The q value is 0, but as an equation, because q is just the name of that point, really, name of that y value. But as an equation, it's y is equal to 0. Remember, it's a horizontal line. Horizontal lines start with y is equal to because they cut through the y-axis. This line cuts the y-axis, so it starts with y is equal to. So you putting this here would let them know, okay, you know what that asymptote is, the equation of that is. Then remember, you know what it looks like that, but it has one point only. It has that y-intercept, one important point, so 0 and 1. So let's just go ahead and put that down. I'll just make that 1, go in order. And so 0 and 1 is here, 0 and 1, and then you just draw your graph. You know it's increasing. This is your asymptote, it's increasing, so it's just going to look like that, pass through there and just shoot up. Okay, let me just push it down so it looks like this. Okay, so that is your graph. It will never touch the x-axis, and you can label the graph because that was p of x, label it p. So we're done with p. Now let's draw the graph of h. The graph of h was our parabola. And to draw this graph, we're just going to go ahead and put down everything. We know it's a smiley face, but let's put down the important points first. The first important point is your turning points, 1 and -8. So I'm going to go 1, that's the x value 1, and then -8, we go 8 units down. Okay, so I just decided to draw numbers as well. So 1 and negative 8 is 1 and negative 8 right there. So we're going to put that. That's our turning point that we have there. Make sure to label it. You don't have to label something like this because it's on the axis. It's on an axis, so you don't have to. But this one you have to. So 1 and negative 8. Let me put that in red so it stands out. 1 and negative 8. And then you have to put down your x-intercepts. Your x-intercepts are 3 and 0 and negative 1 and 0. So I'm putting that down. 3 and 0 is here. So we put that there. I don't have to write it down. It's on an axis. And negative 1 and 0 there. I also don't have to write the coordinates. It's on an axis. Then the last value you have to draw down, or the last coordinate, is 0 and negative 6, your y-intercept of your parabola. So 0 and negative 6, meaning 0 on the x-axis, negative 6 on the y-axis. So there. And I also don't have to write those coordinates because it is on an axis. And now we just have to draw it. So just connect it as best as you can. I find it easier to connect from the turning point to the x-intercept. So like this, from here to there. Stretch it out like that, right? And then from the turning point again to the y-intercept, then to the x-intercept, and then shoot out. So like kind of like that. So like this and shoot out. Not the most perfect looking graph, but kind of like that. Okay, so I tried to correct it a bit. So that is P and then this is H. Okay, I've noticed that to draw it, if you can, when you're drawing the graph, right? So whether you're starting from here or here, if you just focus on your eye on the next point, it usually helps you to actually get there more accurately. So when you're here, focus on the next point. When you get there, focus on the next point and you'll be able to draw it. Okay, and I forgot to label the axes. So X and Y. That's another thing that they mentioned to name. Okay, next question. So 6.2 says, sketch the graph of f. If f of x is equal to p of negative x, using the same axes in question 6.1. So we need to use that graph, right? The axis there. And we need to go ahead and sketch this graph. Let's go ahead and translate and understand what this means. If f of x is derived by saying p of negative x, what does that mean? Well, notice that the x became negative. When the x becomes negative, this is a reflection across one of the axes. So if they make x negative, right? X becomes negative. This is a reflection across the y-axis. But if they make y negative, this is the reflection across the x-axis. Okay, so that's how that works. So it means that the graph of f was formed by taking p and reflecting it across the y-axis. So wherever that graph was, it was here, it will be reflected and it will be here. Okay, so that's what the reflection is. Let's go ahead and look at those graphs and see what's going to happen there. Okay, so remember we're taking P and we're reflecting it. So we're going to take P and reflect it through the y-axis. If you reflect the P through the y-axis, what's going to happen is this. You don't have to overthink this, okay? You don't have to think, where must I put this? And don't overthink it. First thing we need to look at is any points that we have available. So if you're reflecting, and this is another thing I should mention. So when you're reflecting across the y-axis, what happens is you're going to have to think about what happens to the points. In all the points, right? What's going to happen is that your x value will change. So reflecting across the y-axis causes all the x values to change. When I say change, I really just mean that you're going to see all the x values. They're just going to become, should I say, the negative of it. You're really going to take whatever x value you have. Let me give you an example. So let's say this was a point here. It was maybe 5 and 3, right? So what's going to happen with the x value here, which is 3, is we're going to take 3 and we're going to multiply it by -1. And it will become -3. So your new point is going to be -3 and the y value stays exactly the same, 5. So that's what's going to happen. Then let's say with a point here, the x value is just going to change. It's going to become a -2 and the y value will be exactly the same. As you can see now, I'm already showing you what your graph is going to look like. The only other point you would have to look at, the most important point you would have to look at, is whatever point you have on this graph right now showing. That would be the 1. But this coordinate is 1, well, sorry, it's 0 and 1. And remember what I said, when you reflect across the y-axis, it causes the x values to change. If the x values are changing, we're going to have to look at the x value here. It's 0. You're taking that 0 and you're multiplying it by -1. But 0 times -1 still gives you 0. And that's why your point here is still going to be the same. Okay, so you're going to have that one being reflected there, that one being reflected there. This one stays here because 0 times -1 is still 0. So it stays there. And then the next one, let's say a point here. Okay, it be reflected. -1 is your x value. So the reflection of that will be +1, but it will still have the same y value. So in a nutshell, if we look at what the graph is going to look like, it's just going to look like this. I'll try my best to just sketch it out like that. So it's going to look like this. It's going to have to hit there eventually. So like this, it's going to hit the 1 and it's going to keep going down like that. Okay. Let me push it down a little just so that it passes through the 1 like that. And this will just never ever touch the x axis. It's going to keep looking like that. So without these circles, your graph of f is just going to look like this. Make sure you show it intersecting that 1. It needs to intersect that 1. So that is a graph of f. And that's what it's going to look like. Okay, so that is 6.2. Moving on to the next question. Okay, so 6.3 says the graph of h is shifted 2 units to the left. So h gets shifted 2 units to the left. You need to write down the equation for the new graph. Okay, so in order to write the equation of the new graph, they didn't really say as y is equal to, but you can write it as y is equal to. And this is how I would write it. The new graph is y is equal to, and I'm going to actually show you the translation. What actually happened? That graph of h, right? We're just going to take it and move it 2 units to the left. But we need to understand how to apply that translation into your equation. When you see a left or right movement, remember, like I explained in question 5, explain that left or right movements, right, they are affected, or the values that are affected by left or right movements are x values. X values only are affected by left or right movements. So it means that if we're moving 2 units to the left, it means that your x value is going to be affected. It's going to move 2 units to the left. But when you're writing this as an equation, left, right? So we're going to take the x value. That's what's moving. And what are we going to do to this x value? I know it's moving 2 units to the left. And on a Cartesian plane, you would say -2. But in the equation, when you're trying to apply it, if you see left, you need to say plus. Okay? Only for x values. This is only for left and right movements. Left is plus, minus is right. Okay, but then with up and down values, up is still plus, down is minus, always. Okay, so with this one, I have to say x plus 2. That's actually what happened to it. And now I just have to apply it into the equation of h. So I'm going to look at the equation of h, which was this. It was h of x is equal to 2 times x minus 1 all squared minus 8. And what I'm going to do with h is I'm going to apply it here. So f of x or y is equal to, and I'm going to apply this in here. It means that you see your graph of h, wherever you see x, all you need to do is add a 2 to that. So that's what I'm going to do. So I'm going to say, I still have 2 in front. I write that, multiply by, I have x. I see x, so what am I going to do? I'm going to add a 2, so plus 2. Then I still have minus 1, then all squared, minus 8. And then just simplify this. Okay, so that is just y is equal to 2 times x, and then 2 minus 1 is 1, so positive 1, all squared minus 8. And that's the new graph that you have. Okay, that's 6.3. Moving on to the next question. Okay, the last question, 6.4 says, show algebraically that p of x plus 1 over 2 is equal to 2p of x. Okay, so they don't actually expect you to just take this and start fumbling around with it and then say, yay, I got that answer. Okay, so what they expect you to do is actually take p of x, that equation that we had there. So p of x, please remember p of x is equal to 4 to the power of x. I can only say that because I also have it here on a page as well. So p of x is equal to 4 to the power of x. And what we're going to do here is this. We're going to prove to them that this is actually equal to this. So since we know what p of x is, they want us to prove to them that p of x plus a half, right, is equal to this. Let's find out what p of x plus a half is if we apply it to our equation of p of x. Okay, so p of x plus a half, meaning wherever you see the x value in p, add a half to it. So that's what we're going to do. P of x is equal to x plus a half. I'll just say I have 4 here to the power of x. Yeah, I'm writing p of x down, but wherever I see x, I'm going to add a half to that. So I'll say plus a half. Okay, so I've applied the p of x plus a half. I just need to show them that if I simplify this further, it will eventually just be concluded to be equal to that. So let's go ahead and see what we can do. Well, first of all, this is a half. It's not so easy to work with a half as an exponent, but I also see this is 4. I could rewrite this 4 in a simpler exponential form. 4 is 2 squared. So I'm going to rewrite that 4 like that. So 4 is 2 to the power of 2, but that's just the 4. I still have the x plus a half, so I need to apply that by putting brackets and saying it's x plus a half outside the bracket, since this is our 4 inside the bracket. Okay, so this is equal to, and now when you have something raised to an exponent raised to another exponent, what's actually happening is your exponents get multiplied. So now 2 needs to multiply to that x plus a half. So that is 2 to the power of 2x, and 2 times a half will give you 1. So that becomes plus 1. Okay, so this is what we still have. How can we get it to look eventually like that? Can we simplify this further? Well, I can see a 2 because I see there's a 2 here. I can see a 2 here. I can separate these. In the first questions, we actually work with separating exponential expressions further and equations as well. I can separate this into 2 to the power of 2x multiplied by 2 to the power of 1. And you know that 2 to the power of 1 is just 2. There's our 2. That's probably the 2 they got. So where's the px coming from? The p of x coming from? Well, you know what p of x is. P of x is 4 to the power of x. And here we have 2 times 2 to the power of 2x. But if you simplify 2 to the power of 2x, it's really 2 squared to the power of x. 2 squared is 4 to the power of x multiplied by 2. So there we have 4 to the power of x times 2. We know 4 to the power of x is p of x. And so that therefore means that this p of x plus a half, I'm going to simplify 4 to the power of x. I know that that is p of x. That is actually p of x multiplied by 2. See, multiplied by 2. And so that is really just 2 p of x. So that's how we algebraically prove this equation. Hi, grade 11s. So while I was editing, I noticed something about this question. It's not incorrect, it's correct. But the thing is that there was actually a quicker way to do this. Instead of what I did here where I separated them like this, where I first of all made this a base of 2. I actually didn't need to do that. That was an unnecessary step. What I could have done is left it as a base of 4 but separated it from here. So leave it as, now I'm going to separate it as 4 to the power of x multiplied by 4 to the power of a half. So I have my 4 to the power of x, which represents p of x. So I leave that and I'm going to say 4 to the power of x multiplied by, and then change this base. So change that base of 2 to 2 squared, but it still has its exponent of a half, so multiply by a half. And so I will still have the 4 to the power of x multiplied by, now 2 to the power of the 2 squared, the squared, right? And the half will multiply. When they multiply, 2 times a half is 2 over 2. So that is just 2 to the power of 1, which is 2. And so already like that, you see that 4 to the power of x times 2, since 4 to the power of x is p of x, that's really just p of x times 2, which again is 2p of x. So I didn't really need to do that. So we should just left the base of 4, specifically this one where the x is the exponent. So that is the last question for question 6. And then we finally move on to question 7. Okay, so we're on the last question, which is question 7. And question 7 says, the sketch below represents the graph of f of x, which is equal to a over x minus p plus q. Okay, it's in the right format, which is good. And then we have t, which is a point on f. And what they want us to do is this. First question, determine the values of a, p, and q. So basically just find the equation with everything they've given you. So they've not only given you the value of, or the point t, they've actually given you more than that. As you can see, they're showing you the asymptotes. This is your vertical asymptote. The equation of the vertical asymptote is, remember, it passes the what axis? The x-axis. So it starts with x is equal to, and x is equal to whatever number it passes the x-axis at, which is 4. This is your horizontal asymptote. It's a horizontal line. Remember, the horizon is where the sun, okay, that line that you see when the sun is rising. So that's how you can remember that's horizontal, horizon. Okay, and that horizontal asymptote, we have 2. So the equation of that is it passes the y-axis. So it starts with y is equal to 2. Okay, so we have those. Now, what do they actually stand for here? Remember how I said that they put this in the right format? It's in its correct format. In grade 12, you'll notice that they will try to confuse you here and there. They will sometimes say x plus p. Then you need to figure out what that's actually going to be. Okay, just because they changed that to a plus. So you just, whatever that value is, you just, multiply it by -1. But they already gave you in the right format. They gave it to you in the right format. So we just need to figure out what p and q are. P, first of all, is going to be the value of your vertical asymptote. So that's p. And then q is the value of your horizontal asymptote. So that's q. We're just going to have to substitute. That's really all. And then substitute that, and we'll be able to find a, p, and q. Well, we already found p and q. Okay, so let's go ahead and do that. We're going to tell them, first of all, we know that p is equal to 4. And we know that q is equal to 2. I'm going to use that information to find a. So the equation is f of x is equal to a over, and I'm already going to start substituting, x minus p, p is 4. So I'm going to say x minus 4 plus 2. And when I have this equation, do you see that it's almost done? Only a is missing. So how would you find a? You'd find a by using this point they gave you, substitute that point in. So we're going to go ahead and substitute the point t, which is 5 and 3, as your x and your y value. So that's going to be the y value f of x is 3. 3 is equal to a over our x value is 5. So 5 minus 4 plus 2. Okay, 5 minus 4, easy. That's 1. So if you take 5 minus 4, since this is 3, a over 1, a divided by 1 is always going to be a. Plus 2. And then just take the 2 over. So 3 minus 2 is a. And therefore, a is equal to 1. So there, you've found the value of p, q, and a. Okay, moving on to the next question. Okay, 7.2 says, write down the equation of h of x if h is the graph of f where a is less than 0. Okay, a being less than 0 just means a is negative, right? A is negative. So if they're saying where a is negative, you just have to write the equation of h. So h is a new graph, and we form it by making a negative in the graph of f. That's really what they're saying. Let's just write f of x down first. So our f of x is this. So the f of x, we'll just rewrite everything. So a here was 1, okay? So it was 1 over x minus 4 plus 2. So they're just saying a is negative. So just make a negative. That's all really. So it means h of x is equal to, that becomes a -1 over x minus 4 plus 2. Now with this -1, the way fractions work, right? If a fraction is negative, it doesn't necessarily mean the negative belongs to the numerator. It can belong to the numerator, the denominator, or in the middle. to simplify it, to just symbolize that the fraction is negative. It can either belong to the numerator or the denominator, but it's still negative. So I can just rewrite it as h of x is equal to negative 1 over, so negative in the middle, and then we have 1 over x minus 4 plus 2, and that's it. So 1 mark question, very simple. It looks like they're being very lenient as you end off the paper. Okay, then we have 7.3, moving on to the next question. Okay, with 7.3, they say write down the range of f. So the range, you need to think about what the range of a graph is. The range of a graph is all the possible y values of a graph, all possible y values. Okay, that's the range of a graph. So what's the range of f? Well, we know what this graph looks like. This is f of x already. To find the range of a hyperbola, it's very, very simple. Trying to find the range, meaning all the possible y values this graph can have. Look at how this graph behaves. Look at this y value. It has a y value here, has a y value here, here, and here, and then we have an asymptote. So meaning it will never have a y value here. Okay, so that's at 2. It will never have a y value at 2. If you keep going, see, the graph continues. You have a y value here below 2, and here, and then another y value here below that, and here, and you keep having y values till negative infinity. Even if you go up to positive infinity, you keep having y values. So because the range does that, because you keep having every single y value here, and the only y value you don't have is 2, your range is going to be this for your hyperbola. Your range of f is y is an element of all real numbers, but, or you don't have to use words, but y must not be equal to that asymptote 2. That's the only place you will never have a y value. Please also note that this also applies, this works the same with the domain as well. The domain is speaking about all the possible x values. You see, the hyperbola will always have every x value. The only x value it will never have is that asymptote. Okay, so that's our answer there. Moving on to the next question, the last question really. Okay, so we're on 7.4, and 7.4 says, if the graph of f is reflected in the line of y is equal to negative x plus c, so we don't know what c is, the new graph coincides with the graph of y is equal to f of x. Determine the value of c. So if the graph of f is reflected in the line y is equal to negative x plus c, then the new graph is going to coincide or coincides with the graph of y is equal to f of x. Well, to understand this question, we have to understand what the word coincide means. So according to Google, coincide means to occur at the same time. But if I try to look into a more maths definition of graphs coinciding, it seems that to coincide means for graphs to overlap perfectly. So like I have a graph here, I have another graph overlapping perfectly so that they precisely match each other. Okay, and that's really according to ChatGPT. That's really the definition of coinciding in relation to graphs. So let's try to understand what is going on here. If the graph of f is reflected in this line, so we already have our graph of f. Let me actually just put down the graph of f. Okay, so this is the graph of f. If it is reflected through this line, y is equal to negative x plus c. First of all, this line has a negative x, so it's not an increasing function, it's a decreasing function. So it looks something like that, right? It's going to be decreasing. So they're saying that if we have this graph here, if this graph is reflected across this graph, y equals negative x plus c, that the new graph coincides with y is equal to f of x. I'm not sure if do they mean this y, but that's not possible. How can these two? It will never coincide with that. So I guess what they mean is that they're saying if you take this graph, right, the hyperbola, and it's reflected through this line, y is equal to negative x plus c, that the new graph coincides with the graph of f of x. And what they would really mean by that is we're taking this graph of f and we're reflecting it across this line. I guess they mean that it matches up perfectly. When you reflect this one across this line, it ends up looking exactly the same. It matches up perfectly here. And if you reflect that wing over there, it also matches up perfectly. That's the only way I can think about what they are saying. Since they say that it coincides, that they reflect, they match perfectly. They will literally sit on each other perfectly. Well, if that happens, my only conclusion to that is, if that is even possible, and then they say, of course, determine the value of c. If that is the case, if you can reflect the graph of f across this line, which they didn't tell us the c value of, and it perfectly lines up with the original graph of f, the only way that that is actually possible is if this is the axis of symmetry of this graph. That is the only way that is possible. And here's why I'm saying so. The axis of symmetry is the line that if you draw it, you would notice that your graphs are perfectly identical to each other. They said that we reflected this across this line. They didn't tell us that it was the axis of symmetry yet, but they told us that we reflected it across this line and it perfectly matched up with each other, because they said it coincided with the graph y is equal to f of x. And I'm really just assuming that they're speaking about the graph of f because y stands for f. So if it perfectly matches up with the graph of f, then they're really just saying that when we reflect this graph across this line, we still get the graph of f, meaning they're perfectly symmetrical across this line. So that would mean that this line is actually the axis of symmetry. Now, which axis of symmetry is it? I think they made it obvious here because we have two axes of symmetry, the positive one and the negative one. The positive one says y is equal to positive x, okay? And then you have your rest of the thing. That is obviously going to simplify to c. And then the negative one is where you have this. But since they already gave us the negative, I don't see a reason why we should be battling with the positive one. So we already have this. So we just need to figure out, how do we find c? Well, yeah, you actually need the positive one to figure out the negative one. So to find the positive axis of symmetry of a hyperbola, the equation is y is equal to x minus p plus q. It's quite simple because if you remember the general equation of a hyperbola, which is a over x minus p plus q, you will easily remember this because you see x minus p plus q plus q. Okay, so that's the equation of the one with the positive gradient. But you see they gave us the one with the negative gradient. The one with the negative gradient, to find that one, it looks like this. Y is equal to, you really just put a negative in front of the x and the minus p. So it's like negative x minus p, then outside you say plus q. If you distribute that, that's y is equal to negative x plus p plus q. So we're really just trying to look for this equation, but really the p and the q would simplify to c. That's why they have y is equal to negative x plus c. Okay, so let's just look for that. So what's p and what's q? So that's y is equal to negative x. What is p? Now, value of p, we already know that it's 4, and the value of q is 2. Remember, we figured that out in the beginning already here. So 4, and that is 2. So y is equal to, we have negative x plus 4 plus 2. And so therefore y is equal to negative x plus 6. And so you see where we had that equation y is equal to negative x plus c, it means that the c value is actually 6. So yeah, c is equal to 6, and that is our final answer. Okay, so that is the end of this paper. Hope you guys enjoyed it. If you have questions, please make sure to leave your questions in the comment section, and I will see you guys in the future videos. Bye for now.